GM, hello everyone. Let's go. And yeah, welcome to ArbiVerse in Bangkok. We are super excited because this is the first ArbiVerse we have in Thailand. I hope this is the first of many that we have. And yeah, also super special because this is the DevCon week, which is the most important event for the Ethereum community. And yeah, we are here being part for sure. We are part of it. And yeah, my name is Sana, community manager at the Arbitrum Foundation. And I gotta say that it's been a very cool year for the Ethereum and the Arbitrum community, for the entire ecosystem in general, I'd say. And also, I want to thank you for being part of this event, for being part of Arbitrum, and also contribute to its growth. And thanks to the amazing builders, and also thanks to you, Arbitrum has become the most advanced, decentralized, and secure layer 2 in the ecosystem, according to Layer 2 Bit. Also, is the home of DeFi, the home of gaming, and the home of real-world assets as well. Now, as well, Arbitrum technology development started in 2014, and since then, more than 2,000 apps has been developed or also have been integrated Arbitrum, and as well, more than $19 billion of total value bridge have been in Arbitrum, thanks to you, thanks to the amazing community. And as well, Arbitrum is worldwide. Like, Arbitrum has a big presence in more than 130 countries, thanks to our amazing community, also ambassadors, members of the Arbitrum DAO as well. And yeah, every day, like, there are many people waking up and contributing to the wider Arbitrum ecosystem. And as well, in the ecosystem, there are more than 60 Orbit chains publicly announced and more in development. And yeah, how cool is that? Like, there are many teams now working with the Arbitrum stack, building their own customized chain and scaling Ethereum together. These are some of the Arbitrum Orbit chains. So yeah, thank you for keep building with us for sure. And you also will see some of them here in the venue. And as well, Arbitrum, I believe Arbitrum is also a very cool place where you can play video games with your friends, have digital ownership and also identity, a place for financial inclusion, to also tokenize real world assets where you can even send and receive crypto, or I'm also using it to send remittances to my family in Mexico, and yeah, way more. And Arbitrum is for sure a great place to build. Is a place where founders, delegates, Arbitrum DAO members, and the wider Ethereum and Arbitrum community are here building every day for a more secure, decentralized, and against censorship and open source ecosystem. And yeah, thank you. Arbitrum is a better place thanks to you, and every day is also evolving. So make sure to follow Arbitrum main account and also Arbitrum core account in Twitter, and you can also follow these QR codes for you to check the Arbitrum portal and Arbitrum Foundation website. We've always sharing like a lot of alpha, so make sure to be there. And we also want to say thank you to our ArbiVerse partners, is Espresso, Plume Network, Privacy, Phoenix, Open, Arbitrum DAO, GMX, and CoSwap. So yeah, thank you very much for joining this ArbiVerse edition. And this is the general agenda of the day of ArbiVerse. Right now there is a launch happening. We are going to be opening the workshops, and at the end of the workshops, we are going to have a night market with a DJ and also with local food vendors and a lot of cool stuff happening. So make sure to go and visit all the things that are happening here. There is an Arbitrum swag as well booth, and there is a gaming section. So yeah, it's super cool. You should go and check it out. And this is not a secret. The Arbitrum community is full of giga brains. So there is a big hat here in the venue for you to find. And yeah, make sure to take a picture of it. so we can have these pictures together. And maybe at the end we can create a super big collage of it. So now, yeah, let's get started with the workshops. We have incredible speakers today, and they have prepared amazing presentations for you. And also, this is live stream. So hi to everyone in the community that is watching this live stream. And this is going to stay recorded for you. So yeah, good to hear that. So let's get started. We're going to have Alison Korkosh from Open Zeppelin. And Alexander is an open source developer of libraries and tooling at Open Zeppelin and previously was working at Kraken Exchange. And I want to share a fun fact about him right now. So he dropped university and now he's part of the most important security projects in Web3. So yeah, let's give him a round of applause. Woo! Welcome.
Thank you. Thank you so much. So yeah, I'll be representing Open Zeppelin here and all our efforts to build an ecosystem for stylus. So I think we've been developing our project for almost 1 year, and we are here to share what we could make and what problems we encountered. So let's start with design of stylus contract. Basically, stylus is should be compatible with EVM. So stylus contract should be interchangeable. And but for Solidity developers, there are differences, and for there are differences between Solidity and Rust, and of course, its main problems that should be highlighted. And let's go next. First thing is lack of constructors. At Solidity, it's typical object-oriented language, and constructors are same as C# and Java. So, but at Stylus there is no so, and it should be some workarounds been made to be able to construct a contract. Inheritance, it's not like that. Errors, yeah, there is a different approach in Rust for errors. Calling the other contract is also a bit different, and there is another aspect with selectors. So let's dive into the first one. And yeah, as you can see, there is a first straightforward approach for typing your contract. You will be using trait, and in this trait, you'll be using constants. But the problem is that it will be done at compile time. So if you want to execute some code during deployment, it's impossible. But it's still enough to pass some string parameters like name, symbol for ERC71, for example. The other approach you should have function initializers. You can call it init, but technically it will be function exposed, and the deployer should call that function. And of course, you should consider that there is a possibility that malicious actor will call this function right after you deploy contract. So you should also check for address. And this is also not perfect, but I still think that's like kind of first option is preferable. Second one, if you really need it. Actually, at Open Zeppelin, we are not doing neither first one, neither second. So we devised the other approach. I'm not here to advertise it, so we will drop it later. But yeah, it's called COBA. It's basically tooling that allows you to call constructor written on Solidity. So here you can see this is code written on Solidity, just for ERC20, for example. And this file should be placed next to the contract written on Rust. It's not perfect, but it actually can happen like within a single transaction. There are still many problems around this design. For example, you should keep same order of fields because it should be tied to the fields in your Rust contract. And but yeah, it's still something, and we're expecting that that problem with constructors at Stylus will be solved later. Inheritance. So there is no inheritance in Rust. You cannot just take one struct, inherit from the other one. You can use trade, and you can use a syntax that looks like inheritance in Solidity, but actually just generic restriction on types. So there is no virtual functions, so there is no word virtual. Of course, it's reserved in Rust, but no, it is not part of the language. And the other problem that there is macro at Stylus SDK, inherit macro, but it doesn't work for 3 levels of inheritance. So just an example of contract that won't be able to be compiled. So you see top level contract, second level contract contains third level contract. And here is where error will be highlighted by your compiler. Yeah, it doesn't work. Of course, you will try, once you see this problem, you will try to solve it, for example, through this way. And it's extremely dangerous. So you just put third level contract to the top level, and you duplicate it into places here and here. So and the worst thing that can happen with this solution that you will think that it actually works, it can pass test, but in reality you just duplicated your contract storage 2 times. In Open Zeppelin, to hire a new teammate, we're conducting work test, and every person passed through challenges. So the last challenge is mostly related to the project. So we recently hired new teammate, but of course, more people have been passing that work test. And that is one of the problem that every experienced software engineer that passed all previous stages like encountered. So it's not trivial. And yeah, I want to highlight that never do it. So let's go next. Yeah, basically, since there is, you cannot use, if you look at the contract as a tree, and 3 levels, depth of third level is impossible, so you can use it just once. Yeah, and pardon. Yeah, you can use it just once, and of course, it makes sense to use it just in the contract of library consumer. So, and the other contracts not using inherit keyword. So, and it works just in entry point contract. So entry point at Stylus SDK means that exact contract that will be compiled to WebAssembly. So like the least unit of compilation. And the overall approach that you should take, or at least we're trying to take at our library, is using composition, using wrappers, so, and not relying on inherit keyword. So just put one contract in the other, and then let the library user just expose those functions, those methods that he needs. So and of course, in this scenario, it's not necessary to use borrow attributes because it's pointless. It's necessary for inherit macro and no limitation for inheritance tree. So with errors, it can be quite simple. If you need just to use, for example, our smart contract, and you don't want to mess with typed errors in Rust, you can just use row bytes and return them. Just map typed error to vector of bytes, and that's it. it can work for simple scenarios, but for libraries, of course, you should have some more sophisticated approach, because otherwise it would be very hard to test. Let's go next. To make an external contract, for example, you have one contract, you want to call the other one. Classic example is ERC-71 and a receiver. It's widely used at OpenZeppelin Solidity library, and in our library for stylus contracts we're also following. So basically, this is example taken from our code base, maybe a bit simplified without comments, but yeah, doesn't seem complex. Anyway, it's a bit more messy than it's in Solidity, but yeah, and you should pass always top-level storage in call. The other difference of stylus contracts with Solidity is that it's impossible in Rust to have two methods with the same name. It's possible in the other languages like Solidity, C#, Java, but in Rust you can do it. And this is another problem that our contributors, or for example, candidates that have been passing work test OpenZeppelin, like they've been challenged to it. So, and they've been asking questions, what's wrong? So of course, it's solved quite simply. In stylus SDK, just indicate exact name for selector. But yeah, everyone got stuck with that question. Okay, here I want to cover a few topics about designing a library. Previously, I was highlighting design of contract that you want to publish by yourself, and if you want to create some library that someone else will be using. So what you should pay attention to, errors. So yeah, of course, to be able to correctly test your library, to navigate, to have documentation, it makes sense to rely on Rust type system. So, and that is how you can compose errors. Same as you compose contract. For example, current contract, it's a consecutive extension of ERC-71 of NFT. So it contains ERC-71 inside, and same works with errors. You can indicate error in the enum as an argument. For checkpoints, same. You take errors from checkpoint contract and put it there. So errors can be declared in Solidity-like style. Of course, one crucial thing that you should implement method error for all underlying errors. So otherwise it won't be compiled, but it's quite simple. Maybe in future it will be included in this macro, and it will get more convenient. Also, in terms of making your functions public, technically you can just implement methods in your contract without any trade, but we at OpenZeppelin thinks that it's much better approach, more versatile, since you declare the contract just once in the trades, and implementation is left only to user. So yeah, currently this approach will work. So you just declare trade, and using public keyword, you can write your own implementation. Or for example, you want to have a bit different contract from ERC-20. So you can use reuse same trade, but use composition to store ERC-20 contract and basically forward calls to corresponding functions and override those that you don't need. The other good thing about interfaces, I mean trades, in Rust it's called trade, so that you can implement interface IDs. So at Solidity, there is a pattern, there is a standard ERC-165 that allows to show the other colleagues what is exact. So basically validate set of functions of your contract. So, and it relies on one important fact that that every contract has selectors. So, and those selectors compose interface ID. So basically, selector is hash of function signature and name of the function and all types of arguments. And interface ID is XOR of all of those items. Technically, if you change, for example, here, token ID, you will change type, the overall interface ID will be totally different. It's quite obvious that it's like will be a completely different number, and that is quite convenient to at least to make sure what is the actual contract looks like. So at Solidity, it's done quite simple. Interfaces expose property, but at Stylus there is no that thing, and you can just implement interface ID by yourself. So here you can see that we basically compute catch hash and XOR of every selector. Or you can write your own macro. So it's currently exists at Open Zeppelin library, and you can use it. We're using for ERC-165. And then expose function support interface that will check that exact contract support that exact interface. Let's go next. So the other important thing for library is to be able to validate that it works. So to be able to make sure that all test scenario pass, and for example, for us, for Open Zeppelin, it's important to pass security audit and to have for auditors the best tooling and the best environment to check if something works or doesn't. So we implemented end-to-end testing, and yeah, if you're developing your own library, also strongly advised to have something like that. Currently, we are not published yet our library for end-to-end test, since it relies on some infrastructure on Nitro test node that you should deploy, and maybe in future it will be available. But yeah, by the end, for end-to-end test, you should have Docker installed. You should run Nitro test node. It will take some time to set it up, so it's not long process. I think our pipelines take like almost 10 minutes to pass all tests altogether with setting up Nitro test node. For calling the contract, you need some kind of RPC, so you can use EthersRS or LA provider. We use last one, and you should compile your entry point contract. So ideally, you should have some contracts for test, or like we have examples, and every example that is documented, it also well tested. So then you can write test scenarios. Basically, in this test, this end-to-end macro desugars quite simply. It just initializes every account. In reality, underneath it called default function, so it's known pattern in Rust to have a default initializer for a function. So, but in reality, it just calls shell script a Nitro test node that was previously cloned and found that exact account. So that is currently how it works. Maybe it looks quite simple, but in reality, it is not. So, and that is why it's hard to publish it as a separate grade. And same here, we're just deploying our contract. But yeah, again, we're calling something, we're doing some thing with Nitro test node here. So I think we can go next. Oh yeah, technically, as I mentioned, that end-to-end test require more time to pass, and it has infrastructural dependencies. So, and it would be really cool to be able to run your testing suite in memory. So not call Docker container and then waiting for consensus. So unit test could help, like check your contract in very fast way. So as I mentioned, no Docker is necessary. Test can pass fast, and that open way for fuzzing test when you can run single test but with different set of arguments. So many times just hoping to find some error or mistake and then record artifact that produced failure. So of course, you still cannot test it on chain if you're using memory. You can't use it with Solidity contract. You can deploy Solidity contract and Rust contract in memory. So it would be too complex. So you should still use end-to-end test for it. But yeah, and it requires some understanding how basically stylus works. So I'll try to shed some light on it. Basically, stylus contracts are linking, so and they're calling some other code, some library. So and our idea is to mock that call. And at OpenZeppelin, we have a library that's called Motsu. Basically, I don't remember why we called it like that. So it's something on Japanese. We're expecting to rename it to something that sounds better, like Open Zeppelin test. So, but yeah, currently it's called Motsu. Yeah, and what is it doing? It's mocking every call to the host, and it replaces that call with some in-memory storage. So in this example, just every operation with stylus contract desugares to writing bytes, so cache bytes or loading bytes. So there is nothing complex. So we have a key and basically the value that you pass every time. And what you need just to mock that. So, but there is a problem that shame is same for every test. So, and test and Rust are by default run in parallel. So, and technically you need to synchronize them somehow or make it possible to run it in concurrent way. So, of course, you can use mutex for this purpose and store those and for every test, store a set of mock data, mock storage, and also you can store, for example, mock value or mock address that's going to execute the transaction, or how much Ethereum you're going to send. So in our case, at Rust, good thing that every test case runs in separate thread, and it has a unique thread name that basically matches the full name of the test case, module name, and function name of the test case. So what we need to do is just to take the thread name and use it as a key in some concurrent hash map. So in this example, we're using dash map, and it can work. And in this case, all test cases run concurrently in parallel, and basically it is enough just to mock storage data. And that is how test cases can look like. So yeah, Motsu is the name of the library, and the contract is basically exact contract on which you can do some operation in this test case. In future, we're expecting to add some improvements. So, for example, being able to set message sender who's sending transaction, not hard coded, or pass some value, for example, set amount of Ethereum that's been sent, or deploy a few contracts. So, but of course it will be Rust contracts, and I guess, yeah, there is a quite extensive roadmap for mods. So, and yeah, we expecting to implement it. Also, other important thing for your library, since one of the selling point of Stylus is that it should be cheap. So, of course, we are not going to use contracts written on Solidity because in some cases it can consume quite a lot of gas. So, and the good thing is store a footprint every time you add new changes to your library. So run some benchmarks and record those data. Important is that you should pin to a specific Rust version or Nitro test node version. So to make sure that changes in your benchmark being produced not by infrastructure, but by your code. So to better understand what's happening. And that is basically screen, the snapshot of our pipeline for ERC20. So of course, it's possible at Stylus to cache contract and gas price will be a bit less for the call. So it basically 20,000 way less, as you can see. But overall, it looks quite good. I mean, overall Solidity is a bit better, but it's because those are simple contracts. So there is no heavy computations in ERC20, and mostly we are writing to storage or taking values out of it. And same for ERC71. So technically we have much more benchmarks, just a bit what I shared. Also good thing to store in your pipelines to record what are sizes of compiled binaries. So because we noticed that sometimes it can be quite big, and by the end you won't realize what introduced those changes and why your contract cannot be deployed. So I think that's it. Thank you. Do you have any questions?
Oh, thank you very much, Alexander. That was amazing. To be honest, it's super cool to see what you're building with Stylus, and for sure, always great to have the OG OpenZeppelin team doing audits to the Arbitrum code. And yeah, thank you very much. It was amazing.
Thank you.
Woo! So now it's time to hear from Chris Cordell. Chris is an integration engineer at Offchain Labs. As you know, Offchain Labs is a company that started Arbitrum, are the first builders of Arbitrum, and now they are a service provider to the Arbitrum Foundation, and they are still working to the Arbitrum ecosystem. And as well, Chris works on the Stylus SDK and helps teams to adopt the Arbitrum stack. And a fun fact about him is that he's an avid skier and loves to hike and enjoys Latin and country dancing. And I've been noticing that. So yeah, he's really good at that. So yeah, let's go, Chris. We are happy to have you here. Thank you. Woo!
Let's set that up. All right. Do I need to? Do I gotta allow this? Hang on. Okay. Yeah. Will that work? Is this gonna work? If is this working? Can somebody help me out with this? Oh, okay. It's working now. Okay. Okay. All right. Let's go back. All right. Hi, folks. My name is Chris Cordell. I'm good to go. Okay. And I'm going to cover how to implement black shoals in Arbitrum Stylus. My name is Crisco. I go by Crisco, and if y'all need to contact me, those are my socials. But yeah, what we'll cover in this talk. Ooh, goodness. Hang on. What? Let me just do this real quick. You switched. Oh, okay. Okay, cool. Okay, thank you. All right. So what we're going to cover in this talk is black shoals and the implementation of that. This is an equation, a famous equation that enabled the development and maturity of options markets and financial markets. We'll just kind of briefly cover sort of the history of this academic model, how it works briefly enough to like get you kind of familiar with it, but what we want to get to is how to implement this in Stylus in about 100 lines of Rust code, and demo that for you here to kind of show you one of the main benefits of Stylus is that it's really good for computationally heavy transactions. So Black Scholes is a great kind of DeFi type of equation you might want to implement in your own code. So this is a good example of like what Stylus's strengths are. So what are options? Options are financial instruments give you the right, but not the obligation to buy or sell an asset at a given price. Call options are the right to buy an asset. Puts are the right to sell an asset at a given price. Main benefits of options are that it gives you access to leverage, enables you to manage your risk better. You can hedge your bets against how markets move. It's also useful for speculation. There are risks associated with options. You can lose whatever you pay for the option, which is the premium. They're very sensitive to price movements, and you have a limited time frame to exercise them. So if you might be correct about the movement of an asset, but if that asset doesn't move in the direction you intended it to until after its expiration date, then you're out of luck. So that's part of the risk. Options have been around for centuries. These are some of the historical examples of them. There was a earliest example known from history is like in ancient Greece. There was a philosopher named Thales that he was secure. He predicted the weather to kind of guess how good the olive harvest was going to be for a particular season, and he would secure contracts to secure the olive presses when he thought that the weather was going to be really good and the output was going to be really good. So he kind of like monopolized the olive press supply in good years, and he made tons of money from that. Champagne fairs in France were done in the 12th century. And then towards the 17th century, we started to see more formal options markets develop in London. I think, yeah, they called them refusals and privileges instead of options, and put options and call options. But yeah, and then towards the 19th century in New York, Chicago, London, it started to really mature. But options were always haunted by the fact that it was very difficult to price them correctly. It was largely a guessing game to say which contract was fairly valued or not. So they were always kind of limited really until the 20th century. Yeah, it was mostly just based on intuition, gut feel, you know. So the markets were always limited as a result. So some parallel developments kind of led to the formalization of options markets. Some of those are from just physics, and some of them are from just financial theory as well. So in the year 1900, Louis Bachelier wrote the theory of speculation, where he was modeling stock prices as a random walk algorithm, and that's what you see on the right there is sort of a random walk of, actually that's basically pollen particles colliding with each other. And if you were to trace the movement of a single particle within that follows a random walk. And so this theory of stock prices also being chaotic, but somewhat deterministic based on this random movement is, it started to be modeled what we call Brownian motion in 1905. Einstein helped to create the model for that. And then a couple decades later, towards the 60s, we started to have developments around efficient market hypothesis. The hypothesis is that any arbitrage that exists in markets is arbitraged quickly. So anytime there's alpha or whatever in the market, it usually gets eliminated quite quickly. So that's a theoretical idea. It's not always true in reality, but I think over the long haul, this is the way that prices tend to work in practice. And then in 1973, Black and Scholes published, they had developed a formal way to price options, and they called their paper Pricing of Options and Corporate Liabilities. There was a parallel research from a researcher named Merton. His name is not always included, but he's considered as big of a part of this as Black and Scholes are. And if we go on, okay, so after that, in 1973, the Chicago Board of Options was established, and we started to get more mainstream options available in the financial marketplace. By the third year of CBOE being established, volume had increased to like 1.5 million contracts, and today nearly 1 billion contracts trade hands every month on the public financial markets, and that's over $40 trillion in monthly volume. So these markets are huge, and options and derivatives dwarf the main stock market by a couple of orders of magnitude. So again, key assumptions with Black-Scholes is the stock price will follow a geometric Brownian motion, random walk. That means it's just as likely to go up or down at any given time. Arbitrage is eliminated very quickly from the market. There's also the assumption that the Black-Scholes model makes the assumption that you can buy and sell any number of these options. Also, there's no transaction costs or taxes factored for in the equation. So that's something in practice that you have to sort of customize your equation for. And what companies do in practice today is they have customizations of this academic version of the equation. But for demonstration purposes, we're just going to go with the simple theoretical version. All securities are perfectly divisible. In reality, that's not necessarily true. You can't really buy a quarter of a stock or anything like that. But it still simplifies the equation quite a bit. Risk-free interest rate is constant and known. That's another assumption that the model makes, is that risk-free interest rate, when we're talking about that, so it's like the price of government bonds or something that's basically like, a government-based bond or treasury that's has a constant interest rate throughout the length of the contract. So you kind of have to average that out for this equation, and whatever they're paying for T-bills or whatever is what you might plug in for that. Also, that there's no dividends during the life of the option. Dividends are not factored for. All right, couple of important definitions, kind of covered some of these. Call options are the right to buy an asset at a specified price. Put options are the right to sell an asset. The strike price is the price for the asset if the option is exercised. So if you're buying an option for 1 year from now, I'm buying the right to buy, AMC stock at $10 a share. That's the strike price. Premium, that's the price that they paid for the option contract itself. So you might pay $1 for that contract. You might pay 50 cents for that contract in order to have the option to buy that. Whatever the premium is the price you paid for the option. Expiration is the date the option contract expires. For simplicity, we'll probably stick with 1 year for that. There are two primary types of options, so-called American options, which basically give you the option to exercise those options at any time before the expiration, whereas a European option can only be exercised on the date that it expires and not before. And the risk-free rate, again, which I mentioned earlier, usually the yield on government bonds or T-bills, and it's just a theoretical rate of return to kind of compare the risk in the model. So we'll get to that. So this is kind of the formula. This is, I'll kind of briefly cover this, but I don't want to get too caught in the weeds on it because it takes some time to grok this. And if you've never seen it before, you'll probably not understand it on the first go around. But I'm going to cover the variables and, like this is something that if you want to learn more about, I'd highly recommend researching later on. But yeah, essentially we're computing the call option contract. That's the left side of the equation. And then we're going to take the stock price, the S0, which is the current stock price. So what we're trying to do is come up with a fair price for an option contract. So we're going to take the current stock price, multiply that times the cumulative normal distribution of D1, which I'm going to present on the next slide. And from that, we're going to subtract the strike price, which is the price of the asset if it's exercised. So like the AMC example, if I'm buying AMC stock for $10, that would be the strike price. And then I'm using Euler's number raised to the inverse of the risk-free rate times the time to expiration. And then that's all multiplied times the cumulative normal of D2, which I'm going to cover over here. D1, so this, again, this complex differential equation is probably something you're not going to get on first go, but just what I want to showcase is that you can take complex math like this and very easily port it over to stylus Rust code in just like very few lines of code. And that can have a lot of powerful implications for DeFi and gaming, cryptography, and things like that. All right, so we're going to take on D1, we're getting the natural log times the stock price over the strike price plus the risk-free rate plus sigma, which is the volatility rate. So volatility rate in this case would be something like when crypto volatility rate is going to be very high. But in order to compute a volatility rate, you sort of look over the history of the asset and what the likelihood of it going up or down within a particular range might be over the course of that time to expiration. So, with a crypto asset, the volatility rates should be very high. In some stocks and some things like S&P index or whatnot, this would be a lot lower volatility rate. But yeah, so we're just kind of multiplying T minus T is the time to expiration. You see on the top and the bottom, we're just subtracting D2 is just D1 minus the volatility rate times the square root of the time to expiration. The simplified version of all that is at the bottom. Again, it's a lot to grok in a 25-minute presentation, so I'll just kind of show you that this is what we're implementing. And when I go over to the code, I'll kind of bounce back here for a minute and just kind of show you what I'm porting over. But, this is just an academic equation that we're porting to Rust and making it simple to do in stylus. So now I'm going to exit out. I can get the regular to show my screen. Okay, perfect. Okay, cool. Okay, so all right, so right down here, we've got the compute function that is the public function on this contract, and I'm hard coding a couple things in here. So currently, we're just going to go with the asset price as being $100, and that's the S part of the equation. Or S sub 0 in the equation. And then we're going with the strike price of 105. So this is just going to be an option to buy, a call option to buy this asset at $105 in 1 year's time. And the risk-free interest rate is 5%. We're just going with 5% for now. And we're going to say that the volatility rate for that asset is 20%. Okay, and one thing I want to point out that I'm using here is this Rust decimal library. This is a very helpful library if you need to do if you need to do financial equations, it's very handy. It's got a lot of built-in math functions for you. It's a fixed point math library. So when you're working with like in Stylus, we can't support floats. So when you're working with decimal points, using this Rust decimal library is like really good. It's really compact. It fits well on chain, and it works well for this environment. So it's a helpful library that I highly recommend. So when I'm calling this desc, that's just like a decimal macro for that comes with Rust decimal there. And the risk-free rate is 5%. The sigma is 20%. The time to expiration is 1 year. And then we're calling this compute all function. We're passing in those values, and let's just jump into that function. All right, so it's got the discount rate, which is the inverse of the risk-free rate times the maturity raised to e to the x. E to this is the x for e to the x. And so that's from that formula. If I go down here, this part of the formula right here where it's e to the negative r times t that's what this is. This is just e to the x. This is Euler's number, and then that's the x. So we're just porting that over directly. And so it's very simple to like port math over using this Rust library and using Stylus in general. So the square root of the maturity is also where we're taking the square root, I think, from here. Square root of t minus t is the square root of maturity. So that comes up in this equation right here. So we're just pre-computing that. We're taking the square root of the maturity times sigma, which is also exactly from there. Sigma times the square root of the time to maturity. The k discount, which is the strike times the discount. That's the strike times s sub 0 times, where is it on the formula? I think it's over here. Yeah. S sub 0 times the discount rate, which is up here. That's the sigma e to the, that's this part, this strike price right here. That's this portion of the equation there. And then as long as it's over 0, we're going to compute D1 and D2. Those are the D1 and D2 components of this formula here. And D1, we've got a custom function for computing that, where we're taking S over K times the discount, getting the natural log of that, dividing it by the square root of the maturity, it's square root of t minus t times the sigma, plus 5% times the square root of t times sigma to compute the D1. And again, this is just porting this math formula over directly right into Rust. Then we've got D2 is just D1 minus this. We also compute the cumulative normal of D1 and the cumulative normal of D2. Then we get the stock times, this is just more of the formula. This is stock times CDF D1. So this is going back to the original equation. That's this stock price times the cumulative normal of D1 minus this part of it. So that's just minus K discount times the cumulative normal of D2. And all that comes out to this part of the equation. Once we've computed it all, we're going to get the price of the call option, and we're going to log that to the console just to show that. And we're getting it in 2 pieces on this particular example. We're going to get a mantissa and a scale. That's just the way it defaults, breaks up math in the Rust decimal library. We could combine the mantissa and scale into a single 256-bit value, but for now we're just like going to return 2 values here. So briefly, I'm going to run this code. So let's go ahead and zoom in, and I've already got a I've already got a like a dev node running locally. So the contract has been deployed. Deployed it earlier. In fact, the contract was deployed at this address here. So we're just going to call that compute function. I mean, all the values are hard coded here. You could obviously parameterize this if you wanted to, but for simplicity, we're just going to call the hard coded values, but we're going to just use cast. Let me set contract to this, okay, and then cast send. Okay, I think that should work. And so this is yeah, so it should have worked, and then I think we go over here. Yeah, okay, the call price is $8.02. So that was for an asset which you have the stock price, the strike price at 100, and the or the strike price is 105 and the current asset price is 100. So the value of that call option, the price, the fair market price of that call option is $8.02. Okay, so this is just to give you an example of like the types of things you can easily do in Rust and Stylus that are basically impossible to do in Solidity. It's very difficult to do this without running into either, without roughly estimating it or anything like that, or running into stack 2D pairs, or, to do this kind of complex square roots and Euler's numbers and all this. So, yep, that's kind of the demo. And if y'all have any questions, happy to answer them for you.
Hi. First, I want to start by apologizing for my lack of proficiency in English. And
problem.
you mentioned that Stylus is suitable for DeFi.
Yes.
But could you provide any examples of DeFi project built with Stylus?
Oh, yeah.
Given that DeFi requires contracts to communicate with each other, I'm curious if there's any example where Stylus has been utilized to that extent.
Oh yeah, superposition. They'll be here. They have a talk in like I think 1 hour or so. Superposition is one. They'll be talking on their project. So yeah, I highly recommend like sticking around for that. And what was the other part of your question?
Could you provide any examples of DeFi projects built with Stylus?
Oh yeah, superposition is one of them for sure. But yes, there's and yeah, fair blocks here too. So yeah, so we got a couple speakers after me. So yeah, stick around and you'll learn more about those for sure. Yeah.
Awesome. Any other question? Okay, super. Thank you very much, Chris. That was awesome.
Thank you.
And yeah, by the way, like for this weekend, we are going to be participating in the ETH Global Hackathon. So there is $20,000 up for grabs, and Chris is going to be one of the mentors as well. And yeah, actually, as well, there is a surprise for all the developers out there. Like there is an initiative that is called the Stylus Sprint. And yeah, basically there are 5 million in ARB for all the developers that are building something with the Stylus. So if you want to check it out, go to the Arbitrum main account to see the pinned announcement. It's basically there, so you can see and participate in the Arbitrum Sprint. And while we wait for payment, the next workshop, maybe I can share with you a fun fact about Arbitrum. So as you know, the Ethereum white paper was launched in 2013, and then Ed Felten, the Off-Chain Labs co-founder and one of the first builders of Arbitrum, was in his deck in 2014. And in 2015, Arbitrum was being discussed in a classroom. Actually, you can verify that in a YouTube video. If you go now to YouTube and type Arbitrum Princeton, like as the university, you're going to see this video of these students that are talking about Arbitrum under the supervision of Ed Felten. So yeah, that's a super fun fact about Arbitrum. And yeah, so now as well, for ArbiVerse, I hope you are enjoying. This is a very cool event where we want you to feel all the good vibes that the Arbitrum ecosystem has, and also all the amazing teams and also projects that have been building on Arbitrum for a long time, and for sure a lot of new teams joining us. And yeah, as well. Now it's time to hear from Payman. He's the CEO and co-founder of Fairblogs. And as well, he's a researcher at Waterloo, the University of Waterloo, and he spends most of his time on DeFi markets that can be more efficient and credible with confidentiality. And we also have a fun fact about Payman. So he used to be on the water polo national team. Congratulations for that. That's very cool, to be honest. And he likes random facts about octopuses. And yeah, I'm sure that he has watched the Netflix series about my octopus teacher, I believe. Maybe you can confirm that. Yeah, he did. So yeah, let's give him a round of applause. And yeah, we're very cool to have you here. Thank you.
Hello, everyone. Can I have it? It's not working? Okay, anyways. Yeah, make sure to watch the Netflix series about octopuses. It's really interesting, more interesting than you think. And yeah, so it's not working, so I'm going to make a joke in the meantime. So it's working. Okay, good. So I'm still going with the joke. So in Bangkok, you know, like that there is like, I don't know, tuk-tuks, you can have the, I don't know, cab, you can take the subway, and there is like multiple ways, and sometimes you can just walk. So we have the same situation in cryptography. There is like TEs, MPCs, FHEs, like ZKs, and they're not necessarily the best answer for everything. There is no like number 42, like the ultimate answer to all of your problems in your life. And but like there are a lot of people who say that like my solution will solve everything, which is like simply not true. So there is like some kind of trade-offs. I call it like UPS trade-offs. So like the use case, performance, and security. So for the very same reason that you sometimes take a motorcycle, it's faster, it's more efficient, but it has like less security. But sometimes if you want to go to like a wedding, you don't take the motorcycle. You don't need that, like you need more security. And with the same logic in cryptography, if you want to build like something that is very fast or like more efficient, you can use like things like T, but obviously it doesn't have the security. And like there is some like middle grounds with MPC, and if you want to do like very fancy stuff like I don't know, going to the wedding, if like confidential AI stuff, you can use like FHE. And with the same logic, like sometimes when you want to go like I don't know, like really fast somewhere in the middle of the city or like very far, you combine different modes of transportation. And we have the same concept. I call it multimodal cryptography. So sometimes if you really want to build like a very, very secure system, you combine TEs and MPCs and ZK together. It's crazy, but you need that for going really far. And if you really want to do like optimize it in a sense that is faster, you can still use ZK and MPC and T to optimize it and make it faster. So like anyways, like that was the, before starting, like if you really want to build something today, right now, you can just start with the QR code. It just directly guide you to our docs, which is specifically for stylus. And I'm a big believer in blind following. So if you just blindly follow the instructions there, you can actually have an auction like in like 30 minutes. And yeah, so I call like what we are building dynamic confidentiality. We don't use the term privacy because just like we don't want to be seen as like something like Tornado Cash. We can see like, I don't know, we can build much more stuff with confidentiality, and it's about the systems, not necessarily about data privacy and users or like values. It's basically, that's like the reason behind the name confidentiality. the reason that we call it composable is that we don't really want to build like an isolated chain somewhere in the, I don't know, corner of the crypto ecosystem. We want to build like applications with actual users and developers. So we are happy that we are working with like Arbitrum and Stylus, that there are like a lot of great developers and like users, but you can actually do the same thing with like all of the other ecosystems and build there to have like access to liquidity and like other developers to build with you. And the reason behind dynamic or like dynamicity is basically the fact that we have a network that like hopefully one day we can have like all like the optimized cryptography solution, confidentiality solution, either like the most like fastest performant one or like the most secure one or like the, I don't know, something in the middle for each of the applications. So if you want to do something like an auction, which is really fast, we have a solution for you. But if you want to do like confidential AI, we have like another solution. And this is like our vision right now. We are mostly focused on things that are really fast and like more secure enough. And yeah, let's talk about the applications. There are a lot of applications, but today I want to talk about like some stuff that are like newer to me, not necessarily things that you've heard. So my favorite one is confidential auctions. And it's my favorite for the reason that normally when you talk about privacy or confidentiality is always like something that is like a luxury add-on that like you should really care about the society or something, and then like it's not really necessary. But with auctions, it's like something that you can have like a more performant market. You can have like better end prices for the end users. You can have like more competitive markets. And there's a lot of like academic or in papers about that. Like if you really want to follow that, you can read like, I don't know, Tarun Chitra's paper about this. But basically, if you have, for many reasons, like I'll just name some of the reasons, so that you need confidentiality. First of all, like if you want to have like an open price, like first price open auction, there is a problem that like they call it in TradFi, the bid from chandelier, because the guy who is running the auction, they just make up something and they call it like, there's like a really good paper from A6Z, like shield-proof auctions. So like the shilling technique is a bad thing for the market. If you want to make it like a fair market, you want to prevent shilling. And there's also another thing is like incentive alignment. So theoretically, first price auctions are not incentive aligned. So they don't necessarily provide the best value to the end users who are competing to each other. And if you want to build like an actual, like a auction that is both resistant against all of these privileges and like attacks and scenarios that the auctioneer can exploit or like other people in the auction can exploit, you end up with like an encrypted auction or basically a sealed price auction. But it's like a centralized version is not enough. There is also, it's not just because of decentralization as a value. If it's not decentralized, other people like the auctioneer can exploit their privilege. So if you want to build it in a like, the answer is like an sealed auction with a public broadcast, which is like a blockchain for us. And if you build it that way, you also solve a really important problem, which is like the last look problem of the block proposer. So simply when you have like the auction running the auction, the block proposer can see the winning bid and they can like front run that. So for all of these reasons together, you can have like a better prices for end users and you can protect your the market against like all of these like different kind of malicious strategies. And some of like a little bit like more about like where auctions are in DeFi are really important. There are some projects on the intent side that you really want to like, I don't know, make some auctions there. So a good example of that is like CoSwap. We've built something to them. And there is like, if you follow like in TradFi, like there was like Google's auction was actually a sealed bid auction when they had their own IPO. And you can have the same thing with ICOs in crypto as well. One of my favorite ones is like perpetuals. So there's liquidity auctions and like there are some scenarios that if everything is public, people can like force liquidate it because there is like some kind of information in the wild. And if you know that information, you can put some orders and like force liquidate some of the positions. So if it's like encrypted, you can prevent this kind of situations. And there's like pre-confirmations auctions, which is already sealed bid. So there's some projects like Premev who are running like centralized auctions or like not that decentralized auctions. So you can use for the same application. There's like MEV auctions, basically like Flashbots auction is like Sealbit today, but it's centralized. So if you want to build like a decentralized auction for MEVs, you can use it the same. Obviously, RWAs, like in many countries, they are selling houses with Sealbit auctions. NFTs. One of the cool things about NFTs is that like one of our projects with Stargaze is the reason that they are using Sealbit auction is not about like the fair market or just like cryptography or privacy. It just makes the whole process faster, because right now with the open auctions, they should delay the whole process with one block. But if you make it Sealbit, you can like conclude the whole auction in like 1 block, 2 blocks, not wait like for 10 blocks. So these are all my favorite examples, because like, of course, like privacy and cryptography is like has a lot of value for us, but there are also some kind of very direct monetary designs that having privacy and cryptography like saves you some money, like in a very direct and immediate way, or like basically makes it like a better application for your users, and you can have like more users because you are more competent compared to other projects. And the other kind of things that I'm personally excited to build on Stylus is like, I call it like social-fi, game-fi, PvP markets, but any kind of application that there is like multiple parties involved and there's like a shared private estate and you want to combine them, can be a really good idea. There is like a lot of ideas. Poker, which is real-time, is a good example. Ask me like later if you want to learn more about that. There's also ideas about like prediction markets or like pari-mutuel markets. In both cases, you need some kind of confidentiality. One interesting thing about like, for example, Polymarket is that they are using UMA, and UMA is basically using like naive like hash commutable schemes. And if you really want to make it like decentralized, you can use something like this to make the whole like Oracle like somehow encrypted, but without relying on the like Oracle operators themselves. Yeah, obviously verifiable randomness generation is like something that is used in many like DeFi or like gaming projects. And one of my favorite things in general in games, like outside Web3, is there is always this kind of mystery boxes, and then you go to the next level, you unlock something, either for yourself or for the whole community. You can basically encrypt something, put it on chain, and then like set some kind of conditions. And once those conditions are met, you can decrypt it for yourself or like some kind of community. So there are like, you can get really creative. We've built like some of these funny stuff. You never know, like some of these like funny examples in crypto get really big. And yeah, why is Stylus? So Stylus is very interesting personally for me, because like I'm coming from cryptography background, and most of the cryptography libraries are in Rust because of performance and security. And it's basically really hard to write like code, cryptography code in Solidity. So you can like, so the first reason is that if you want to write cryptographic code on a smart contract, you can use Stylus. And it's not like somewhere without any users. It's somewhere that people can actually develop and have access to like a good user base. And the other thing is like composability of like other tools that are available in the whole ecosystem. And yeah, one thing that turned out to be very interesting for us when we are selling it to other projects is like the permissionlessness. So whenever like all of these like cryptography projects that we have, one of their challenges is that like you either like you should co-process everything somewhere else and just send the outputs to another chain, or you should update the whole chain like with precompiles or like modules and like all of the other like approaches. But with Stylus, it's like permissionless. You don't need to like install like a precompile for specific ideas. You can actually run it like decrypt, at least on the smart contract side. And yeah, so I want you to, yeah, this is the QR code if you want to start building. Before everything, I want to show you like talk a little bit about the logic of the auction and how like we are going to build it, and like a little bit on the cryptography side. Basically, what we want to do is like we have like multiple parties and they want to encrypt their bits, right? Very simple. So you encrypt the bit, and all of the bits would be included in the blocks so on the Arbitrum side. And once the deadline for the auction is reached, we simply fetch a key and decrypt everything and see who is the winner of the auction. But there is a catch. There is no centralized party controlling the key because we are running decentralized key generation. So with decentralized key generation, you can generate like a master public key and a master secret key in a way that nobody is actually holding the master secret key in one place. And like they can only reconstruct the key if like 2/3 of them are working together. So that's like the idea. And we specifically use identity-based encryption. The reason behind this choice is like it's very fast. Like it takes like 5 milliseconds on the encryption side. It's not like ZK that takes like minutes on your side. And the amazing thing about identity-based encryption is that you only need to run the DKG algorithm only once, and then you can reuse the whole like secret shares and everything. And the better thing is that if you have like a batch of encrypted bits or like any kind of transactions, you don't need to have like secret sharing or like other kind of cryptographic heavy operations for each of the transactions. You can do that once for the whole batch. So for example, if you have like 100 bits and 100 validators, you don't need to generate 10,000 shares. You can only have like 100 shares. So the scalability makes it really practical. So I don't think we have time to actually like deploying everything. So I've just done it myself. And yeah, let me just show you the code really quickly. Okay, so the reason, if you follow the tutorial, the reason that we have like, I don't know, 5 contracts, cryptographic contracts, is that like we couldn't put everything inside the same contract. There's some limitations. So if when you see like Cha-Cha 20, like IB contract hashing, don't panic. It's just different like phases of our cryptography. And a little bit of explanation. Cha-Cha 20 is a symmetric key encryption scheme, and IB is the identity-based encryption scheme that we are using. For optimization purposes, we are combining these 2 cryptographic schemes. We first encrypt the whole bit with the symmetric key, and then we encrypt the symmetric key with identity-based encryption. This way, the ciphertext doesn't grow like, I don't know, really big. It's just like limited and more optimized. Don't panic. It's a very simple technique called hybrid encryption if you want to search. And basically, yeah, let me just run the code so it would be more exciting. Yeah, I didn't know anything about this. Like I didn't write the code. My co-founder, he got sick. And I started running this like 40 minutes ago myself. So it's actually possible to build it in an hour. So that's a good thing. Sorry, say again? Okay, sure. Yeah. So yeah, I already like deployed the contracts and everything, and I'm just like running it to show, like give you what's happening here. Like I just put like 2 bits, like 100 bit and 150, and then once the deadline of the auction is reached, it automatically fetches the decryption key from our committee, and yeah, decrypts it and see who is the winner. So one of the interesting things here is that you don't actually need crazy cryptography. You don't need to prove like your bits are like, I don't know, like correct with ZK and then compute over them with like FHE and all of the stuff that takes like minutes. Here, we simply use like some kind of cryptography that is really fast on the user side. But since it's only pre-execution privacy, we can compute like at like maximum level of efficiency after decryption. So this is like one of the things that I call like dynamic cryptography, because yeah, the last step of art is simplicity. Thank you.
Any question from? Yeah. Awesome.
Yeah, thanks for the talk. I have a quick question about the identity-based encryption part. So I'm not familiar with this at all, but I read somewhere that there's some kind of like centralized party involved in those kind of schemes. how do you mitigate this? Are you using DKG for this to make it decentralized? And then the IBE part, how is this implemented? Like, what are you using this for exactly in this case?
For sure. Yeah, so IB, like if you search on Wikipedia, it says that it's like centralized, but if you use DKG, like any other kind of MPC algorithms, it would be like completely decentralized. And you can actually make it secure with like more fancy like cryptographies, like tracing algorithms, or I don't know, like TEs for like corruption risk that normally people talk about it if you're interested. Yeah, so like in general, we just use DKG. And the good thing about IB is that we just run it once. You don't need to run it every single block. And regarding your second question, we are using Bonner Franklin IB. And yeah, it's just like enough. Thank you. Any other questions?
Sorry, just to follow up, is the code open source, or is there like a white paper or something on this?
Yeah, so
especially
there
the
is
IBE
my
part?
paper and thesis. There's like explains the IB part. If you go to our, like, it's just like for 3 years ago, but it has all of the details. It's mostly about MEV prevention, but the same flow holds. And if you go on our website, fairblock.network, there's like more details about like all the kind of applications that you can build. Obviously our Discord and like Twitter, if you can send us a message, like we would love to help you to build like any application. And in the same QR code, maybe I can just show it quickly again. Yeah, we have really, really good documentation, at least for the stylus example. If you want to build, like, it just takes like, I don't know, maximum 1 hour to run it, and then you can just change it to your own kind of application. And yeah, obviously, if there is anyone interested to build like perpetual markets, options, or any kind of DeFi markets, ping me. I would love to help. Thank you.
Thank you very much. That was an amazing presentation. Thank you. And well, we are going to have a 10 minutes break. So maybe you can go here outside, grab some food, also go for the merch that is in the ArbiVerse and in the gaming zone. And then you can come back, and we are having 2 more workshops and more fun facts to come and surprises. Thank you. We're coming back in 15 minutes. So see you in 15 minutes then. Awesome. So we are back, and yeah, we have the GigaBrain hat on. We are ready to hear more about superposition. And also with us is Alex Beige. He's the CTO of Fluidity Labs, a team hacking DeFi incentives, building Fluidity Money and superposition. And a fun fact about Alex is that he likes the Arbitrum Pepe memes. Actually, if you want to get the Arbitrum Pepe memes, you can join the Arbitrum Stylus devs Telegram group. Is Arbitrum _ Stylus. And also he's in his free time, he's a stand-up comedian. So yeah, he's super funny. So let's give him a round of applause. Happy to have you here.
Thank you, guys. Thank you. And thank you very much for the warm welcome and also for inviting me to come up on stage like this and talk about this thing. I want to say something. I'm not actually a stand-up comedian. I'm just a funny guy, but I'm not actually funny in a funny way. It's kind of like in a, whoa, watch out, this guy's crazy kind of way. Not in like a, yeah, you know what I mean. So I wanted to talk today about how to build a lending protocol that powers a yield-bearing stablecoin using Stylus. So frankly, I'm going to let you guys in on a little secret. I didn't actually get this thing done in time. So the code is there. This was supposed to be something very interactive where you pull down a repo and you have to progressively make your way through it. I didn't actually get that done in time. So what we're going to do is we're going to talk a little bit about that, and we're going to look at it, and then we're going to start reviewing the code. And I'm actually going to show you guys some examples of Stylus working in practice in our context, as well as in the context of, you know, what we've built here. So disclaimer, none of this is financial advice. I'm not convincing you to use any products. And most importantly, this is a purely technical workshop. So yeah, so the format obviously was going to be like this, but what we're going to do is we're going to focus more on the Stylus bit, some of the lending protocols, and I'm going to talk a little bit about that. And then I'm going to talk a little bit about LUSD, which is Liquidity's, stablecoin that they've built that's built on top of ETH. So yeah, this is where if you want to get the repo, I highly encourage you guys to download this. This isn't fully up to date yet. I actually have to push through the, the changes, so we'll do it while we have the code up on stage. But you can kind of see a little bit here. This is sort of like a QR code if you want to grab it yourself. So when everyone puts down the phone, I'll take away the screen. Just some instructions on setting up Stylus. You know, Chris has informed me that this is an audience that knows their stuff, so I'm not going to linger on this for too long. So we're just going to move on. And also just got an explanation here of Rust. I guess show of hands, and this will help me figure out the pacing of this workshop because we're going to be here for a little while. Who here has worked with Rust before? Whoa, that's like what, like 8 people? Okay, that's not bad. So I'll just quickly touch on the way that this works and, you know, some of the details about this. This is just some example code here, just to show off the built-in types, you know, just some stuff like, I'm going to walk over here a little bit and hopefully they're okay with me moving in the center a bit more. You know, how to construct the collection types and, you know, how to, you know, import a package, whether that's a part of the standard library or not. And just some more of an example here about how this works, you know, defining structures, defining something called the option monad, which is, you know, an enumerated type where you've got a couple of states you could go through. You could go through a sum state, or like a nothing state, you know, instead of having like a null or like a whatever, depending over languages. Just some more code here. This is an example of implementing something called FizzBuzz. And I guess, show of hands, who knows what that is? Who's right to, okay, there you go. All right, then we got 3 or 4 people. Okay, that's fantastic. Okay. So yeah, this is this is an implementation of FizzBuzz with a little enumerated type, just to show you guys how you might use a short-circuiting feature that Rust gives you, which is this question mark, where if something is none or something is error, it will break the whole thing out, and then that way you can kind of have no if branching inside your code. Instead, you can just kind of like work your way through it gradually. So the EVM, this is a very, very, very high-level representation of how the EVM functions. You've got the node, which picks up a transaction, picks up, you know, a bit of information about the transaction, like, you know, the from, the to, you know, the call data, some of the Ethereum value inside of it. And it supplies that information to the EVM, which then persists storage and then persists logs. So storage is very simply, oh, actually, the next slide's next. Yeah, just to recap, this is how it works. And I'll explain the storage component in a minute, I guess. So the node picks up a transaction, takes some information out of it, and then it uses that information to actually unpack and supply it to the EVM, which is where the EVM then generates something meaningful. So I think we're all aware of this because we're all building an Arbitrum. We don't know how this kind of works. So I've just got an example of how a Solidity contract you write might actually compile down into EVM bytecode. This is in a macro preprocessor language called Huff. So you can see here, you've kind of got your function, you've got some global storage. It might translate into something equivalent to this, which is where, because you defined a public variable, it actually defines like a getter or something. And if you have the increment there, it actually obviously does something, which is, you know, increments what you're doing. So you can kind of see that's a little bit of what I have here. And that's just kind of like an example of how this works. So the EVM, it's just like a classic, you know, stack-based language where you get some features we can interact with the stuff that you get here. So that's pretty simple. So that's sort of like a completed picture of that. And when you go to store things, what happens is that you store things according to a key and then, you know, to a value. So, you know, we're all familiar with this. This is the storage trie. And what I'm trying to do is I'm trying to dispel, kind of trying to take the concept of the EVM and translate it simply into the way that we would interact with it, which is just storage, logs for the most part, right? And then everything around it is just the computation and the work with that. So yeah, the EVM lifecycle, that's all this really is. It emulates it, then it persists some things, log or storage. So, hey, we're here for Arbitrum. So who here is familiar with Stylus, has worked with Stylus? Oh, we got a nice count here. That's fantastic, amazing. So the way that Stylus works, till there, okay, is you write code which produces WASM, and you take that code and then you actually upload the WASM and it gets converted with an ahead of time interpreter into native code on the code which actually interprets the node. So from your perspective as a programmer writing stylus WASM code, you're actually going to be either going between the EVM or a sort of WASM VM, which is actually native code, but we'll just say it's a WASM VM. So why WASM? And I'm sure this is something that the team, really questioned themselves and thought about for themselves. And I honestly think the number one reason why WASM in this context is because WASM is an evolving specification that gets a lot of look, a lot of insight from different people involved with WASM. So not just browser people, we got blockchain people, we got people doing whatever. And it's like a specification that is constantly evolving. So from what I understand, they've extended the spec at one point to include single instruction, multiple data operations, which is, I don't know if you guys have ever worked with like lower level code, in like the context of like a classic like processor, for example. Processors are very sophisticated at working with work like that because they have a lot of internal parallelism that makes them suitable for large operations over like a vector, for example. And WASM has support for that as far as I understand with the spec that they have. And there are a couple of other specs that they've had exposure to that could be useful for us, because with the way that the stylus environment works is obviously you take your WASM and then you compile it to native code. If you have large, like operation support inside the bytecode language, then that translates more succinctly to the native host's code. And yeah, it's just really interesting. And also because it's an open spec, the team can make decisions about which features to add and which features to pull. Like I know, for example, Stylus doesn't actually support any floating point operations with the WASM environment that they have natively, so that functionality is not supported. It's really great. So they can just kind of pick and choose, and they can even get something off the internet, which really simplifies dev time. So that's really fantastic. Another thing that I think is really important, this is also probably why they went out of their way to use Stylus, is that other programming languages and optimization pipelines support WASM to different extents. So a good example is if you write Rust, for example, which obviously we're working with because we work with Stylus. There is a backend which actually generates WASM, which I think it uses the LLVM toolchain to work with from memory, and that's really fantastic because you actually get exposure to that stack, which is really amazing. So, and then also you get access to a pretty broad range of tools and packages and things. And I don't know how many of you guys are working in cryptography. Yeah. Got a few? Got a couple of hands? Okay, that's good. So you could pull down a crate, like you could pull down that GNU math library, for example. What's the one I'm thinking about? The high precision library. You might find a version of it which doesn't have the libc dependency, as far as from what I understand. You could use that. You could maybe pull down a crate which has been in use in production somewhere for working with a specific type of curve or something, and then it spits out WASM, and that's just really convenient. That's great. It brings you to market faster. You can be surer about your code. And you can get that native experience that other blockchains have to actually modify the node and do like a fork to support like the operation, which is fantastic. So yeah, I'm now going to touch a little bit on the way that lending protocols work. And this is a very high level oversimplification in some cases. I've tried to focus more on the borrower UX as opposed to the UX that you might get with the rest of it. And yeah, I'm going to focus a little bit on compound here. This is compound V2 math. For figuring out the utilization rate, just the interest rate, obviously, and then the exchange rate, which you have with this accounting tool that they have. So, a lending protocol is one or two different types. You either have one where it's peer-to-peer, and I go to my friend Ivan over there, and I go to Ivan. I'm like, hey, I want to write you some debt, and then you go, this is the interest rate we want to do, and Or another one is a pooled type of lending protocol where you have a pool of assets and then you have a measure of the amount that's been used and the collateral that's been supplied and these different things. And this is the compound context. So this is sort of like the UX of how it works at a high level. You have your borrower, then they supply assets, and that's the assets which is collateral, and then they pay an interest on it, and then exchange the pool gives them some assets back, and the supplier pockets the interest on the assets that they lend out. So The borrowers supply collateral and they receive assets in exchange for suppliers, and the interest rate is figured out by the borrowing, and the borrowers pay this and the suppliers receive the interest. So yeah, that was Compound V2. You might have like some lending or something, which is kind of fun. Compound V3, I'm sure a lot of you guys have seen Compound V3. It's really great. You have different markets, and then people lend different assets to the market, and people can create different markets and set the different interest rates, and lots of UX improvements as well. And if you get liquidated, you get converted to the base asset in the market where you've actually done your thing. And I honestly think this UI is a good example of what I mean. You can see there are multiple assets here, multiple different types of collateral, and then you can see there's different. Yeah, you can see the net borrower APR and the net supply APR, which is great. So that's on Arbitrum USDT as a base asset. So you can see there are a few different assets there, and this is managed by the DAO. So I want to talk about Aave. Aave is considered sort of like a challenger, or at the time, to Compound. It came out, have a couple of different things that they've done. It's really amazing. They've released stable and variable rate loans. With Compound, you would pay a loan, but that loan would actually be paid according to the utilization in terms of the interest rate, as well as what's set with the DAO. With Aave, you can actually go out and then get like a stable loan for a little bit of an extra fee, but the interest rate will be stable. So maybe you want to lock in a price when the market's good or something, and they've also got a couple of modes here, a siloed mode and efficiency mode, but I've actually kind of forgotten a little bit exactly how this works, so I don't want to touch on this too much without making Aave seem different to what they actually are. And then you get this thing called the safety module, which is a bit of cash that gets set aside to protect people from a situation where maybe you have like some bad debt or something in the protocol, and then you need to take someone's money or something to do like a liquidation. So, and you also have a single asset pool that's different from Compound. We have multiple asset pools. So yeah, we've got a challenger to Aave here, which is Morpho Blue. Morpho Blue is very interesting. They've got this concept called the liquidation incentive layer, which is based on a kind of pricing of like debt, I think at the time, of like the asset or something, and that's actually how they do liquidations from memory. And they've got this concept of permissionless creation of markets, where you might create a market which is not a single market like you saw with Aave, or more like a borrower thing, Compound thing, I think, from memory. And you could have a member, someone that manages the risk on that by modifying the interest rates, managing that. I think it's very interesting. The collateral also isn't lent out, and they've got a different redistribution process for bad debt, which is they just sort of, the words they use in the white paper is socialize the losses, Morpho Blue. So. And then you've got something which I thought was pretty interesting. This is a research paper that came out a month ago. This is called Agile Rate. This is about using a type of function called least squares regression to actually do interest rate optimization by looking at like data and information and stuff like that, instead of having an active fund manager modifying the interest rates. So when I say active fund manager, I mean like a DAO, for example. I like this. This is very interesting. I wrote a lot of speaker notes about this. So if you pull down the repo, you're going to see this. Ajna is very interesting. It's a type of lending protocol where you don't actually have any governance. So there are no managers. It's entirely governance free. You can create a market very quickly, and you can see the interest rate, and the cyber information is priced with a kind of like AMM looking model. And yeah, the risk of like figuring out, like managing bad debt and like understanding how to like lend properly, the risk has been moved from the fund, like from the risk manager, which is a DAO, to the lender. And it's very interesting. I mean, you can really see with the UI what I mean. You can kind of see that they've got like I'm going to zoom in a little bit. Okay, can everybody see that? Yeah? Fantastic. Okay, you can kind of see that there's a concept here of like the price of like when you lend out, extracting yield and stuff like that. So it's kind of fun. I think that's kind of neat. Has everyone had a good look at this? I see some people really zooming in. Yeah? Okay, fantastic. We'll move on. This is another thing, Instadapp Fluid. This is interesting. This is this is more of a Compound-like lending protocol from what I've observed. With the idea is that you have this sort of like a similar mechanism for liquidations from what I've observed to Ajna, which I thought was kind of unique and interesting. They have a very reduced set of things you can borrow from. It's only stables, because these guys, Instadapp, they have a pretty substantial product suite, which is they have a whole bunch of trading, a whole bunch of other stuff. And you can use your lent out position as collateral, I think, for making swaps, which is cool. So it makes sense in the product context. Unfortunately for me, these guys have the same name as one of my products. So Fluid USDC, you look it up, you get these guys, you know, much to my my dismay and despair. So yeah, comparing everything. I've tried to create a neat little chart here because a lot of these different things are at odds in different ways. You've got some which is more complex, but it's liquid, or some which is where it's not so complex, but it's, you know, fully liquid, some not, so whatever. You've got a concept of many markets, and, you know, the many markets might be simpler, like you can see Compound and Aave in the bottom left there, but, you know, you get less flexibility with the kind of markets you want to make because the risk manager is centralized to the DAO. But you can see Morpho, which is considered kind of like a challenger to Aave, actually a little bit more complex, but they've got more markets, which is pretty sweet. So, and then you got Ajna on the top right there because it's a hell of a lot more complex if you're a lender, but you get a hell of a lot more flexibility with the markets, which I thought was really unique and really interesting. And I've got a third quadrant there, which is, in my opinion, there might be some challenge in terms of like bootstrapping and launching these projects. If you were to do everything from scratch, the market doesn't have any familiarity with what you're building. I'm calling this the growth hacking index. So the growth hacking index, Compound and Aave kind of exist, and it's a lot easier, I think, for them to kind of come up in a fresh world compared to Morpho and Ajna, because with Morpho and Ajna, if you're lending, you're participating in a market, you don't just click on the market, participate. Instead, you have to think, oh, do I trust this risk manager? But with Compound Aave, it's like, oh, do I trust the DAO? Hell yeah, I trust the DAO. That's like a billion people. I mean, you know, like, everything will be fine. So that was lending protocols. Stable coins. So I have an oversimplified definition here that a lot of people might disagree with, which is I'm looking at things as only two definitions. You only have over-collateralized and under-collateralized. And under-collateralized is the context of an algorithmic stablecoin, something where you might want to go out and then, I don't know, like you borrow something and you get something back. So that's kind of fun. Over-collateralized, maybe it's backed by fiat. And the reason why I say this is because I'm looking at things as a holistic systems perspective where you externalize the risk of whether an asset is backed by pushing it outside of the system. So if we take a system which is, you know, this Web3 environment, and then you imagine everything in there is accounted for and it exists. If you have something like USDC or USDT, for example, that asset is vested outside of the Web3 environment. So it's almost like an externality, which in my opinion would make it over-collateralized, because if you externalize the management of this, it's almost like everything you have on-chain is one-to-one backed, because it's like a black hole. You couldn't verify it on-chain if you wanted until someone figures out how to do reliable 100% verification of like reserves of fiat, which is not going to be possible. Under-collateralized in the sense that if you take an asset like LUSD, it's backed by lending, and, you know, presumably if there were to be like a bank run, everybody leaves the market really quickly, something, it'd be crazy. And I think for the potential for something to be run on, or, you know, like underwritten in some description, that's what makes it algorithmic and under-collateralized. But, you know, I guess that just kind of depends on your outlook at things. So that's the way I'm looking at it. So you can see this is kind of how a stablecoin works with a lending protocol. You know, in a classic lending scenario, someone supplies assets to the pool, they repay it, you know, they have collateral. With an algorithmic stablecoin, supply assets and you get back a dollar-denominated debt representation, which is always going to be pegged one-to-one. So it's kind of similar, you can see. Not quite. So yeah, LUSD, Liquidity USD, is very interesting. It's something where you supply ETH in this example, and you get back a token for it. And then they have this whole thing, and you don't actually pay an ongoing interest rate like we talked about with some of the other systems. Instead, it's like you just, you know, you pay an upfront fee, which is figured out by everybody. And that's kind of fun. You still have to maintain your collateral, keep your collateral at a certain amount. They call it the collateral requirement. I think it's like 110% or something. But you don't have to pay an ongoing amount, which is kind of nice. So I guess that makes sense in the context of people coming and going, and maybe you want to trap liquidity in the stablecoin system they have here. So yeah, you can kind of see what I just talked about. You supply $200 ETH in collateral, you get back maybe like, I don't know, what, 200, this is 1-to-1 or something. And you just have to maintain the collateral, basically. You don't have to pay an ongoing amount. So yeah, we're going to be building a stablecoin. I've already built it. My plan was, again, to walk you guys through it, how you might do it. And then everybody busts out their laptops, and then they have this piece of paper, which is in my bag. I should have taken it out. But, you know, and it sees like a list of different things. And I was going to give you guys gold stars for every test you get passing. But I mean, I didn't do it. And also I got called up to come up a little bit earlier. So I didn't really get the time. But yeah, very simply, we're going to supply staked ARB, which has recently become a thing, or becoming a thing. You know, where if you go to vote, you get back staked ARB. So it's still a productive asset. You don't just supply your ARB to participate in the DAO. And we're going to pay an ongoing interest thing, and we're going to give you back ARB USD. So the product context here, and I'm speaking from my perspective, I work on a product called Superposition, which is a layer 3 orbit chain. This layer 3 orbit chain has stuff that needs to be maintained, like oracles, for example. And, you know, we thought, hey, you know, why don't we use ARB the whole way down for everything, kind of, you know, keep ARB in the game. Because, you know, I mean, you use your ARB to provide a, you know, like infrastructure, for example, if you wanted, but, or with ETH, you stake, you know, you make the thing. But, you know, what often happens with blockchains is this: you don't participate in a blockchain for the sake of it. You participate in it for the dApps. So they'll have like a native dApp or something. Like, I mean, do you guys remember Friendtech? Show of hands who remembers that? Yeah, I'm getting a couple of nods. That's fantastic. Okay. Friendtech, you know, use Friendtech, you go to base, you know. We want to be doing something where you want to use 9 lives, for example, which is our prediction market. You would go to Superposition, and we need infrastructure to maintain that. And if we were using ARB to stake infrastructure at like the base level to, you know, like validating or whatever, then you might want to supply and support all the dApps on your product as well, just because that's actually the value driver is the dApp exposure. So yeah, just in my example from before, I'm going to zoom out a little bit. You know, you want to, well, it's still zoomed in. Amazing. You want exposure to ARB still, upside exposure. You want to use your assets in a productive way. You want to build staking infrastructure. You also don't want this to be a consumer-facing, quote, stablecoin. So you want some way of rewarding people who participate in your thing, but also pressuring them. Because if you think about it like this, with LUSD, you pay a fee, you on-ramp to the LUSD token. That's fantastic incentive for supplying liquidity into the product, investing it. Let's imagine instead, in our context, we want to build staking infrastructure that actually forces assets to be productive. If we take an ongoing fee, it's going to destroy the supply gradually of the staked asset. If people aren't productive with it, they're not making fees from it. So that's why we keep it in this kind of system. Does everyone understand what I just said? Because that's complicated. I'm getting some nods. Okay, think about it like this, okay? So you've got, on the one hand, you've got incentive, okay, which is like this. Incentive to use a product, a stable coin, maybe for the vibes, maybe for the ecosystem, you know, whatever. That's fantastic. That's what LUSD is like. You pay a little on-ramp fee here, and then, you know, that the liquidity gets vested, and it's kind of like a vicious cycle of trapping liquidity. But what if instead we just want people to have exposure to ARB in the context of an infrastructure provider, right? Where we don't necessarily care if they off-ramp from the token, because this isn't a commercial play. You know what I mean? This is more of an infrastructure play. We can add an extra level of pressure, which is the downwards pressure, which is ongoing fees, that puts pressure on you to earn an APY on your stablecoin by doing things with it. That makes it a productive asset in this context. So that's why the fee design is like this, if it makes sense. So yeah, same mechanism as Liquidity. They've got this concept of troves, which is kind of like you have like maybe like an NFT and it represents your debt position. Yeah, without an upfront fee, obviously, and then more compound and slide. So this is a high level of how this thing could be built with Stylus. I've built all of this. I'm going to walk you through it. I did this for the talk. You have a factory that creates a lender with a proxy, creates an ERC20, and then it uses that ERC20 with a lender. So the reason why I wanted to use a factory to do this is actually to show you guys that this is possible with Stylus very easily, because this is a pattern we've used a lot with our product 9 lives, where maybe you want to make a prediction market or something and you need to create a campaign. So now this is where I would kind of segue you guys into a part 1, which is where I'd ask you to complete number 1 of the tasks, which is just to build this thing. I got a little bit of a hello world and I just try to build it, but obviously we don't have the time. Got an example here, how to build how to get this function passing, and then this is the fun part. This is at a very high level how a stylus contract looks. Generally speaking, you have a macro which creates something called the entry point, which is it exports a function that knows how to look at like selectors, for example, and then like check and see if you're actually running the code, for example, the correct way, if you're allowed to. And then you've got the implementation down there, which is what actually gets connected to that code we just talked about. And a thing there which says storage, and that's basically says, oh, this should be used in the context of being with this implementation. So, Open Zeppelin, I think they spoke earlier, right? They did? Fantastic. Okay, amazing. So then they would have talked about Matsu, I'm hoping. Okay, so Matsu is their macro environment for testing in a unit test context, as well as having a couple of the. I remember how we spoke about the EVM, where you have the storage and then you have the logs, and you need to have some functions exported to the environment to actually do that. And Matsu, that does it for you. So this is a good example of what I mean. This is something called property testing. Developers, who knows what property testing is? Okay, no one. All right, this is great. I'm going to help you guys with something very interesting. You want to build more reliable code? This is how you do it, okay? What you do is you define invariants for your code, okay? And then you use something called property testing to do something called shrinkage of your code, which is where what it does is it comes up with a range of inputs and it binary searches them. So you see the num argument here? This will pick a random number from any number, actually, in the one undersigned 128-bit integer range, and it will recursively chunk it out, try to bake your program. So you would have some independent verification that your code's maybe working correctly, and then you would actually confirm it. And that's what we've done here. So that's kind of fun. This is an independent way of figuring out if FizzBuzz works. So the factory code from before, that was kind of fun, just to see that it does an ERC20 deployment, does a lending, token deployment. This is an example of what I mean. Deploying proxies inside Stylus it's fun, it's easy, it's accessible. You need some bytecode, obviously, beforehand, which can be a little bit of a pain. You have to go online, Google minimal viable proxy or something. Copy paste, okay? Split it up into two variables. You can see we've done this here. And then you get a function, where you can kind of combine that with like an address or something. We're doing that here. Pretty cool, pretty easy. Creates a lending protocol, creates ERC20. That's kind of fun. And also in this example of this code that I've written for this talk, it actually uses Chainlink's price feed to figure out if your collateral is actually on point. It does the scaling, does all the work for you. Only downside is it will break if Chainlink gives you a negative result, because thankfully we're not trading oil futures, so I hope that that's okay, because I don't know if ARB will ever become a negative asset. Imagine if it did, who knows? I don't know. And this is a Python pseudocode that actually represents the borrow code, and also that's not actually up to date. I made a change to this before. This code, tilde, prevents him from going over the borrow rate. I'm actually going to open up the code, okay? And because that's actually fully up to date. We're going to get that open. Okay. So we've got some code here. It looks like this. This is very literally a compound-like bit of code. It just basically just has like a concept of a security deposit and some other stuff. So if you were to extend the liquidator code in this function to actually support incentives for liquidators, it would presumably pay them a part of that after it uses it to service the bad debt, maybe. And this code basically prevents them from going over the collateral rate, and it begins to sort of maintain time points, which is the concept that's used for this. So. Now here at this point, we will be going through the test, but I'm going to skim through it, and we're actually just going to go into active mode. And while we're into active mode, does anyone have any questions they want to jump out at me before we continue? Because this is a lot, and then we're going to keep going. Yvonne, can you ask me a question, please? I'm going fantastic, bro. I'm going fantastic every day. Amazing. Even better, this talk is still kind of half-baked. I'm using an environment called Acme from Plan 9. So Plan 9 was an operating system that came after Unix, where everything was a file. So if you wanted to use like a socket, for example, you'd open a file, you do whatever. I've taken the text editor from the Plan 9 port, which is a variation of that kind of like built out for the Unix environment, I would say. And I use that. It's good. I have billions of programs to compose it, play with it, automate it, the whole thing. So yeah. Pardon, sorry?
Looks like this. Looks like a snark.
It looks like a snark.
Yeah.
Oh, I don't know about that. I'm not sure, but that sounds very interesting. We'll have to connect after and I'll ask you more. Okay. Anyone else? I'm going to go to talking about this. So this is how you might implement a function like that in Stylus. So I showed you guys how you do contract state with a FizzBuzz contract. I've got something very similar here. Unfortunately, Stylus is lacking in the department of constructors, except for the work that OpenZeppelin have done, which is really fantastic, where they've actually figured out how to append constructors, but it's not like a native Stylus feature. So everything you do in Stylus is going to have probably something pretty similar to this, which is just making sure that you've actually set the contract up. No one's trying to override it or whatever. Usually when you write Stylus, you use the sol macro to create the storage state for the contract. But for me, I prefer this approach because this is kind of something that we've developed because we were one of the earliest users of Stylus. And I'm going to show you guys what I'm talking about. So this is math implemented with a scaling factor, but you can kind of see that this is pretty similar. Just some like stuff here involving time points, gets like the time with a chain link Oracle interaction, I think there. Does it? No, it doesn't. Oh, there you go. If you were using Stylus, you've got a lot of stuff you could be doing in terms of like decimal point libraries, floating point libraries, fixed point libraries. All of these things will work. But in this code, for this example, trying to keep it simple. Originally, you were supposed to go in, jump in, replace some stuff, and then you get the test passing, you get the gold star, you leave, you're like, yeah, I got a gold star, but it's not how things develop. So borrowing, very similar. Just gonna create some space here. Borrowing is very similar. You can see this is the Python reference implementation, and then internally borrowing is basically like this. Another thing with working with the Rust ecosystem for blockchain development, I would say, for Web3 development, is easy access to a suite of native features built into the unsigned 256-bit integer type that you get with Stylus. Involving, like, for example, checked math operations is very easy without blowing up the whole environment, because obviously Solidity lets you do that. But you could do things like complicated control flow here, like what we've done with this little question mark symbol. You could go out and you could do some stuff involving, let's see, there's a time point thing here. You could extend, the slot of this thing very easily, maybe play with it a little bit. It's very fun. It's very simple. A lot of the time what happens is that you might get like I'm going to show you guys something from my code in the Longtail, which is our AMM, the cheapest AMM in the EVM space, let's hope. I'm not 100% sure. You might get a function like this, which is a multiplication division of something and then overload it or whatever and just use it everywhere, basically. But in this context, just for this example, we were just focusing on scaling factors. But you could use a Rust decimal or something very similar. It's very fun. One thing I love about working with Stylus is that it's very, very, very easy to come up with ideas and then to validate them very quickly. So what often happens is that a member of our team goes out, they write some Python code, a certain researcher on my team writes some Python code, and he's a non-programmer. And he comes up with the ideas of what it should look like, and then we come up with the invariants, and we translate that into some tests, which are very, very, very easy to produce, comparatively speaking, in my experience with the Stylus environment. So you can see that this on the left here, this is hypothesis testing. This is with a Python package. It's the same concept as shrinking and shrinkage. You can see here that composing it with the contract state, features that they give you with OpenZeppelin's Matsu code, you can actually just slam the crap out of your contract very easily. You don't have to learn how to use Echidna or anything. You can just, bam, I want to use a property testing package. I don't want to use something external to Solidity where it's maybe you'll have to maintain something else. Does anyone have any questions? And is there anything anybody would like to look at? Because I'm just going and doing a little show and tell over the code. First person to put their hand up gets a point from me. I'm waiting. Okay, I'm getting some hopefully some satisfied stares into there. You look like you were going to ask something. Pardon? Got it. Well, thank you for coming anyway, and for paying attention. This is a grind, and but you're getting through it. So yeah, you can do some stuff like this, where maybe you can have your code just slam it, basically, just like slam it as hard as it possibly can. Oh, we got a question. Hello.
No, it's not exactly a question. Is it okay if you use like VS Code or something, because it's quite unreadable?
I don't have VS Code downloaded. I'm sorry. All right, Vim. We're gonna try Vim. Okay.
Yeah, that's better actually.
All right, busting it out. Vim, here we go. Okay, all right. Is this better or worse? Because I see this is white as the background. All right, let's see if I can set the color scheme here, huh? How do you do this? Color? Desert. Oh. Okay, who knows how to set colors in Vim? No one knows how to set colors in Vim. Okay. Okay. I actually don't know how to set. Oh, you do? Hit me.
Okay, so you mentioned a lot of things that are easier with stylus when
Mhm.
writing something like this. Could you mention something that's more challenging?
I absolutely can. That's another easy thing to talk about at this thing. Okay, it's talking about hard things. Look, there's a lot of things you're going to struggle with stylus, especially if you're a first-time user. And stylus is fantastic, and I'm so proud to be playing with Arbitrum and to be even just be rubbing shoulders with the people who worked on stylus, because they're some of the most talented and passionate people, and it really goes to show with what they've been doing. I would say the number one challenge you're going to experience with stylus, and also, how do you feel about this Vim? I might take this off the screen because I can't zoom it in. I can't zoom it in. I don't know how to do it. I have to recompile my terminal emulator to do that. I don't know. No, it's not supported. It's a simple term from suckless, so I don't have to. Okay. It's st. We're just gonna config.h. We're gonna modify the size of the text here, guys, which is hopefully here somewhere. This is becoming a bit of a. All right, there we go. We got size. Okay, I'm gonna make it, and then I'm gonna. Oh, it broke down. Oh, that's not good. All right, I'm sorry. I got to give up on the ghost with this one. This is too much. I'll leave it open. I'll zoom it in for you. Yeah, look, there's a lot that can be harder. For example, dealing with issues that pop up in practice. Like I've noticed some people struggling. They build their code. It accidentally uses a floating point interaction behind the scenes. Like if you use the unsigned 256-bit integer library that you get with Alloy, even just using Alloy will actually behind the scenes use a floating point. And then if you get that, bam, that's going to hurt a little bit. So you will struggle with stuff like things breaking suddenly without understanding them. You might even get a little too cocky sometimes and try something like this, which is if you're like me and you tried to do something you thought would make sense, which is where you try to make it a. Actually, I'll show 9 lives instead. Actually, so if you're like me and you actually use nonce mining to figure out the locations of everything for a deployment. You might, getting the deployment scaffolding can be a bit of a challenge. It's not as simple as working with the rest of the EVM stuff. And just, yeah, so I guess really just to answer your question again, just because that was a lot I just said. Random stuff breaking down for no reason. In fact, we actually had a bug with our AMM where we actually identified a problem in the Rust compiler actually with the WASM code generation. And you don't have access to a native WASM stylus testing environment unless you run it on the node. But when you get a memory trap related issue or something on the node, because, God forbid something's really gone wrong, which is what happened for us, God help you finding that problem. Let me tell you, but things will get better. I mean, the team working on it, they're fantastic. They work so hard. They've done so many amazing things. Everyone should be very proud of what they've been doing. So yeah. Anyone have any more questions? Or I'm going to continue the show and tell. And I'm going to change where I go based on the feedback the audience gives me with their faces. Let's have a look. Oh, hello. Don't want to do that. So yeah, this is the contract lender, which is what manages all of the state and stuff like that. How do you invoke Chainlink, for example? Let's have a look. I'll show you. You'll find yourself doing things like this a lot in stylus. This can be quite painful sometimes. You'll find yourself branching on the architecture of the target of the calling you're doing. You can see here that we want to interact with Chainlink. We check if we're on the WASM host, and if we're not, we go and give you a subbed out version which returns their scaling factor, 1-to-1, which is kind of like, no, that could be better, but that's okay. Pardon? Sorry? Where would I not be when I'm testing? You might actually, for example, there's something here in this code I'm going to show you. You see this function here, borrow testing, and the branching inside of it? Number one, I've got a package I've been building actually, which you've heard about, which is actually a new test runner for stylus. So you can actually add it as a backend for running your stylus code. And in that context, it might be preferable to avoid using the chain link WASM unless you enable block forking, which is actually something that it will support, where you bring down wevm, you revm, you get like the feature, and you just like bang, you're off to the races. You can actually use a point in time to call chainlink, which is kind of fun. But another context might be like this, which is where you see this borrow testing function. This is only going to be active if you actually go ahead and have the testing feature enabled when you do the deployment. Maybe you want to have a function which lets you override the mocking of the thing there. Or you want to do something like this, which is where I have an end-to-end test in JavaScript, which is right here, where we actually do the whole UX of deployment, testing, everything. It's all in JavaScript. Maybe you want to maintain the ability to override the behavior for Chainlink, for the call, just to mock it out and test it in that context. I don't know. But yeah, normally calling Chainlink kind of looks like this. And by the way, if anyone has any questions, just pop up with your hand, and I will see you and say something. Using Chainlink, as you've seen, is very simple. It's like this almost. Similar story with the ERC20, which is you just create this, and then you can actually use this macro here, which is really convenient to actually generate the ABI, packing and construction depending on what you're trying to do, which is really great. So. Yeah. Anyone have any questions? Because I have a fun part of this thing we can talk about, which is I'll walk you guys through the superposition product stack and suite. And I'm sorry. Let me show you. That's a really good question, and I should have spoken about that. So good call. Let me jump to that right now. And thank you for your question. Liquidations. You break the collateral number here. What happens is that it will figure out how far you've gone past it, and then it will just basically take all your collateral and absorb it into the pool, and really hope that you don't actually shoot below the point where there's really bad debt on the protocol and there hasn't been a real shock. Maybe like a member of the Arbitrum team accidentally fat fingers a sell button or something and drops that token by like a ton. In like a minute, you do like a ton of liquidations. But you've actually identified a critical flaw with this, which is there is no incentive for someone to call the liquidation function. There's a security deposit in this code, but there is no payment of a portion, like a portion of the security deposit to the caller. So, very good question. Yeah. I imagine if we go ahead with using something like this in practice, we'll actually modify it to work properly. Okay, we're going to talk about superposition. So before we continue, superposition is made up of a few people, and we have been building. Oh, hello, wrong one. We have been building a lot of different stuff. We're calling this the blockchain that pays you to use it. So when you bridge your assets over, we extract yield on your behalf. We pay it out to you using technology we built using Fluidity, which looks like this. This is kind of like a stablecoin asset we made once upon a time. It's not the stablecoin asset that we're showing you, now. It's actually just like a classic non-custodial using Aave behind the scenes. And yeah, it pays you to do things. We've released a couple of unique products. We've released an AMM. We've released a domain thing, which I just failed to open. So I might, there we go, got it. We've also released the world's first implementation of a dynamic parimutuel market model, which is a unique type of prediction market. So this is kind of fun. Oh, it's cut off. There you go. A dynamic parimutuel market model is actually the world. It's a special type of special type of prediction market which has come up with in the early 2000s, and because back in that point in time, everybody and their dog was using a prediction market. Google, HP, this is the early 2000s. IBM, from what I understand. And people would trade futures on whether a product would succeed or whether a product would fail or whether they would get something done on time. And the reason why we don't know about it in Web3 is because we will use different language for it. We refer to it as an order book when they called it a double continuous auction. That's what they called it back then. And we took a research paper called the Dynamic Parimutuel Market Model, and we developed it and adapted it and built it onto Web3, which is really, we think is really cool. And we did a little thing here, and we'll do some more eventually. We're going to launch some new markets soon, so it's going to be kind of fun. And also, PerStream unfortunately doesn't work on my laptop for some reason. I've never figured out why, but this is a website where you can donate to cats all around the world. I think in China, I think, and you know, you donate to the cats, they get fed, you know, which is kind of cool. We don't actually feed them. We donate to cat charities. So if I had a working web browser, I would actually show you what I'm talking about. But you'd see a cat eating. You should check it out, guys. It'll work on your phones. Per.stream. Yeah, it'll work fine. We didn't build that one in stylus though. So I got some domains. We've got an AMM, the first AMM. Oh, I'm in trouble clicking. The first AMM built using stylus. We've done gas comparisons. We found when we did our gas comparison, that was actually the cheapest AMM in Arbitrum. We compared it against everybody. So super cheap. We're not that smart. Thank you, stylus team. This is in testnet mode. It'll be out soon, pretty soon, actually. And yeah, right. I guess we're kind of shaping ourselves up to be a bit of a stylus shop as it goes, you know, because stylus is so amazing. It gives you so much flexibility with development, testing. You can go to market sooner. I honestly think there's going to be a lot of innovation in terms of the development experience with testing. Like someone's going to come out, you know, maybe me, I hope. Someone's going to come out, do a thing where you can go out, you can test your code very quickly, and you know, test it in the WASM environment. And yeah, do you have any questions about anything I've just shown you, or any remarks, anything?
This is your next big project. This is your next big project, the long tail. Okay.
This is a really good question, actually. We're launching this. As far as we're concerned, the code for this is completed. It's going to have some liquidity mining stuff that needs to be fleshed out. Our next big thing is 9 Lives' product roadmap, which is going to be really interesting. We're going to create a social model here for where there is incentive to create new markets. We're going to actually design an oracle also built on this model. We're going to call it the infrastructure market, which is going to be a nice, you know, oracle replacement for using like a natural language oracle. We hope it's based on a concept called URL committees, and we'll be giving people access to some ZK tooling, which will probably, you know, work with someone else to get or whatever for verifying that the URL contains some content or something. And, you know, also just like, you know, random stuff like, will this product succeed? Will this product succeed? We're going to be building a futaki that powers the governance for that, we hope. It also guide a lot of the product decisions. And later down the line, we're going to be releasing an intent-based order book exchange, which is actually solved off-chain, settled on-chain, and it will actually compose everything we've built on our chain. So if you release your AMM, you know, you say Camelot, you want to bring your deep expertise of liquidity or whatever, you launch on our thing, you know, we will actually use that alongside everything else to actually solve trades for people. We'll leverage that bridging UX that we're going to get with a couple of partnerships we've made that are really strategic, so that you can on-ramp from anywhere, make trades from anywhere, sell anywhere. It's going to be like cow swap if you go to use an exchange instead for the process of solving the trade, as opposed to just clicking, I want this for this, and then makes you an offer. So, yeah. Oh, thank you, by the way, Chris, for that question. It's very good. Thank you.
Hello. So you're using the stylus. Does it mean that you are not writing your smart contracts in Solidity?
No, we're using Rust the whole way down, which is what I'm showing.
I'm quite new to stylus. So for example, since you're writing this in Rust, how do you manage to find those standard, highly audited libraries, like Open70 libraries? Doesn't that increase your cost for an audit, for example?
That is a very, very, very good question. Wow, and I can see you've thought about that a lot as well. Frankly, there's no science. And I think what we try to do is we take a conservative approach with the libraries that we use. For 9 Lives, we use 1 library, really, as far as I'm aware, which is considered substantial. All of this is no consequence, really, but then there's one here called Rust Decimal. We just try to keep the count low. This is also the recommendation from the stylus team, is to use this library. We found that it's pretty good. Some packages you can't be 100% sure about, obviously. So I guess the strategy that we take and that I would recommend to you is just be very conservative with your use.
Thank you.
When is mainnet? Guys, I'm going to drop you a fat alpha bomb here. Well, that's a funny word, alpha bomb. We're going to do superposition mainnet the week of the 18th. So this is finally time. If we delayed, it was a delay. It's been ready. We're feeling pretty good about things. We feel like people will be able to play with this soon. I guess while I'm here, there might be some members of the community still watching this stream, from our community. I just want to thank you guys for being so trusting with us and also just being so patient, because I know it's been a little while, but, we're really thankful and appreciative of you guys, especially, because you've been so great. We love all the feedback you give us, even when you tweet at us with funny memes. And I even saw a very funny meme last night about one of our guys, about our community, one of our community manager, and just like he gets roasted occasionally on Twitter. It's very funny. We all look at it, we all like it. So yeah, thank you guys. So, and thanks for the question, Vaughn. We've got 8 minutes left. Anyone have any more questions they want to ask? Yeah, next week. Yeah, next week. That's actually, I should have said that. Yeah, good. There you go. Tendency to overcomplicate things, tendency to simplify things. Fantastic. Well, the main challenge when we were building the... Oh, pardon, sorry?
The main challenge when using a stylus for you? Everything was like fine and crystal clear? Or?
It's a really good question. I like to think of things like the pre-audit for stylus, post-audit for stylus, because pre-audit for stylus, we were in the trenches, things were changing constantly. We had stuff with code size. At one point, we actually forked the stylus SDK, modified and optimized the code size just to get it working. That was before the team did a really great job of reducing the code size, even more than we possibly could have. We also did things like identified that the interpreter at the time had a memory leak, not the interpreter, the allocator had a memory leak, and we also cut that out, realized it cut the size down a lot. That was fantastic. But that was like, Jesus, man. Like, that was like, we're in the trenches. We had someone on the team at that time that were really fantastic. One of the best people I've ever worked with. They were so creative. Their name was Elle. Elle would really going into it, really getting into the deep, doing things like looking at like constructions of the bytecode to identify problems with it. That was hard. We learned a lot as a team about testing. We made a lot of mistakes with testing, a lot of mistakes with the security of the thing. I remember we went to do an audit at one point. We actually, at that time, realized the day before the team, the sales team had actually released a full-on update to the tool chain, which had actually broken the version of the tooling that we would use. And I had to delete all these JavaScript end-to-end tests the night before an audit. And I was like, But thankfully, a lot of the people we work with are so patient, they're so forgiving. And, the auditors that also looked at long tail. I mean, thank you guys for working so hard and looking at that thing. And we're just really appreciative. So, yeah, but that was before. So to answer your question, was it hard? After, hell of a lot easier. The guys, they're so available, they're so responsive. We worked with Derek a couple of times to just get some advice. He was really, really great, and we're just so appreciative of that. And also, it's become a lot easier just because everything is stabilized. Everything is easy to work with. The profile of the code size has gone down a lot. Yeah, it's just been a lot easier. There are some general technical problems I can give you, though, if you're interested, that are just issues with the design approach. But I would say it's not that. It's been a lot easier.
I'm new to Arbitrum. I may be wrong, but I think my investigate Arbitrum is EVM compatible. So you have to cover all the EVM compiles with stylus, right? In that case, if your stylus is also safer, would you like to port it to cover other EVM compatible programs, for example, program for Ethereum?
I'm sorry, I didn't hear the first part before you got the mic super well. I don't want to do.
I'm sorry. Arbitrum is basically EVM compatible.
That's right. It's a multi-VM.
And you have to cover all the EVM precompiles in stylus, right?
You could access them, I think, if you want. Actually, that's a good question. I've never actually accessed a Actually, no, I have indirectly by using the KCAC online. No, that's not a precompile. That's an operation. Yeah, you can access the precompiles. I believe. I don't know that.
Testing. It's just like calling a regular Solidity contract. You just pass in the address for that precompile, and then you just
So-
provide the interface, the
There you go.
Solidity interface for it.
So actually, I can use stylus to program for Ethereum.
Oh.
Right.
Not for the Ethereum mainnet, only for Arbitrum.
Only for Arbitrum.
Yeah. Actually, wait a second. There's one thing I'm going to say right now. Only on Arbitrum. I want to get into the light a little bit. There you go. Any more questions? Anybody? Oh, we've got another one. Oh, by the way, thank you for your question.
This DEX you showed fluidity, yeah?
Sorry, that's a stable coin, it's a fully non-custodial Aave-backed stable coin. So,
Which is the DEX that you just showed?
the AMM I just showed you guys, this one, long tail.
So the underlying mechanism, is it something of its own, or is it a clone of a DEX, so like Uniswap or something?
That's a good question. I honestly wish I could say we built something super unique. In some sense, we have. We ported it to Stylus. We figured out how to do it. But frankly, we're standing on the shoulders of giants with this one. We took a lot of inspiration, heavy inspiration from Uniswap with this. 9 Lives is more of a very unique thing. No one's ever done anything like this. With this AMM, we're just not smart enough. We're not creative enough. We took a very heavy inspiration from Uniswap with this one. Yeah.
Thank you.
And also, thank you for the Uniswap team for actually open sourcing and making available what you did, because we really appreciate it. And thank you for your question. Anyone else? Oh, so we've got another one. Yeah.
Hi.
Hello.
All right. Thank you for the explanation.
my
I think that you're sure you are showman.
I'm a showman.
Yeah.
Oh, thank you. I'm very flattered.
I think that it's a secret.
Oh, well,
Yeah. And I have a question about stylus.
Okay.
When we compile it with the stylus, you compile it with the sample. It generates you an API that you can use to do requests with libraries for like with 3GAs or E3GAs for the calls from front-end interactions.
Oh, you're asking, is the calling environment the same if you use ETH call, for example, to interact with?
Yeah, exactly. For example, when you deploy in Solidity, it generates the API that you use for
do that.
the script, and it's like
Really good question. I'm going to show you how we do it.
All right.
I'm going to show you guys how we do this in practice. So what we like to do in practice is we give you guys a special Solidity file, which is the interface. And this is what we use to generate the ABI for the calling. The Stylus team actually produced something which generates all of this if you want. And it's so easy to use and so amazing. But I guess for us, old habits die hard. And this has also been the source of Code Arena vulnerability submissions for us, that we did it separately. But yeah, this is the same. So if you were to compile the Solidity context inside this project, you would get access to the ABI the exact same way. Wow, almost out of time.
All right. Thank you so much.
It's my pleasure. And thank you for the kind words. Guys, I see on this thingamajig that we only have 40 seconds left. So I just want to use this opportunity just to ask you that if you're interested in this kind of thing, to check out my friends on Twitter. And I also just wanted to thank you guys for coming along, and also thank Arbitrum and the Stylus team for also working on something like this, because it's really been really fantastic, and we've just been so happy doing it, and we're really appreciative. So, and thank you for emceeing, by the way. Yeah.
Yeah, thank you, Alex. It was super cool to have you, for sure. Yeah, everyone is excited, and yeah, to be honest, this was a great workshop. Like, you show a lot of information about what you're building in superposition, like all the new innovations you bring, and all the possibilities that now are possible thanks to Arbitrum Stylus. So yeah, thank you. And now it's time to hear from Comet and from Jeremy de Tichet. He's the CEO of Comet and also is the president of Ethereum France. And yeah.
All right.
Let's go. Woo.
Are you ready to make history with a capital H? Woo!
Yeah, we're ready. And
Okay.
good. Yeah, just I want to say something more about you, that you are also an associate professor in economics at CNAM, an engineering school in Paris. And as a fun fact,
Oh, yeah.
He was responsible of a large reorg on the Ethereum proof of work testnet in 2016, and he feels sorry about it. But yeah, that's something very interesting. Let's go.
Indeed, it's getting harder and harder to find the testnet ETH, right? So I started my career in the ecosystem by doing some mining, and at some point I wanted to have a lot of ETH from Robston, and what I ended up doing is just putting my miners on the testnet. Well, here we go for the reorg. So I'm here to present to you one cool byproduct of Stylus, one cool byproduct of the fact that we have now an alternative VM in parallel of the EVM that is super powerful and can run super fast. So I was already introduced. If you're looking for me, I have the same handle everywhere, JDETYCHEY. We're hosting ETHCC. I hope to see you there. If you enjoyed DEF CON, there is a similar event as DEF CON happening every year in France or around France. So hopefully see you there next year, late June, early July for ETHCC Cannes. And Comef is a company that's been in business for about 4 years now. We are soon going to celebrate our 4th anniversary. We do account abstraction most of the time and things around account abstraction. And what I'm going to show you today is something that we can use in account abstraction. That was the initial motivation of building something like that. And we work with companies like Gnosis Metri, WorldCoin. Cosmic Battle is our latest game, because we have a game studio inside the company that runs on an L3 on top of Arbitrum. So we are like piggybacking of what we are building inside the company. And this QR code here leads you to a Connect kit that is account abstraction in a Connect kit on a cool website done by Kaiko, where you can get on-chain price on Arbitrum. Institutional grade on-chain price, because they are signed by Kaiko on Arbitrum. So I'm going to replicate only on Arbitrum. All right. It's not using Stylus yet, but yeah, that's a good thing we can do around Stylus with this. Actually, having a powerful VM let us also write weird or not EVM-based cryptographic curve like SegPit56 R1, and we should use that for that. Okay, so now onto the real business. How to build a permissionless multi-chain indexer for EVM blockchains and also non-EVM blockchains. So it can also work for non-EVM blockchain. This should be noted. It works really well for proof of work blockchain, but yeah. So throwback from February 2024, our team was in Denver for the hackathon done by Stylus, by Arbitrum, notably on Stylus. And we worked on the first prototype on this. Back in the day, it was called Storilus. We have a new code name for this project now. And it won a couple of awards during the hackathon. And it got us interested in pursuing this kind of work, open sourcing it, and hopefully convince other people to help us build that. Well, again, I'm quite humbled to be here today because, well, what I'm seeing around the Stylus ecosystem and all the different development that is being done and the amount of brain juice that is being powered into this ecosystem, the thing that we have been building is just a pretty cool utility, but it's not rocket science, so it's hard to execute. So hopefully you will be interested and keen to help. So here is for the problem. Like we had a few questions from the previous talk about how exactly does it work on the Arbitrum Stylus side? Like, is it a precompile? How do you access the precompile? About the EVM, what is the EVM, and so on. You can ask me some deep question about the EVM, not too much about deep question about Stylus. I can answer a few of them. But one cool thing, or what not cool thing about the EVM is how much history we can access. So did you know that when you are speaking to your smart contract, asking him to retrieve data from the blockchain, the only data it has access is the data from the previous 256 blocks. Did you know that? Well, you came to the right place, right? You learned something today. So there's no way to access previous Ethereum state, nor transaction hash, nor anything at past 256 blocks. And that's quite a problem. And there's an EIP coming in, the Pectra hard fork, that's going to help, 2935. Those kind of EIP that you don't really read about. You're like, oh yeah, historical hash, blah, 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 blah. It's going to help from the history query perspective, but it's not going to be full. You only get 91, 92 blocks, not 256. That's a bit better, but not so great yet. So this is going to help a bit, and still a lot of chains are going to continuously face this kind of problem, and the non-EIP 2935 chains are also going to face this problem. But yeah, well, okay, what is it used for? What do you want to actually access a lot of data this way? So there are use cases in DeFi, in airdrops, in cross-chain interactions that can be leveraged from that you can do for that. You can also confirm the user ownership of an asset across chain or at a certain period of time. You can also prove that you've been using a protocol by saying like, hey, this is a transaction that I interacted with the protocol back in block number 23, and we are at block 10,023. So you're able to prove this kind of thing. You can also prove to be the owner of something at a certain point in time, because you're like, hey, at this block, I was the owner of that, so I should get this or get that. From certain protocol perspective as well, when you are bridging out of, if you're in the Arbitrum ecosystem and you are bridging out to another thing in the Arbitrum ecosystem, sometimes you get a super cool boost and the bridging out is instantaneous. But most of the time, it's an optimistic bridge that you have to accept the delay. Having a proof that you actually own the asset that you are trying to bridge out or bridge in is going also potentially help the interaction between bridges and across cross-chain protocols. For us as a account abstraction focused company, it helps us on managing smart accounts across different chains. And this was the initial motivation on working on that. And honestly, storing a lot of stuff on chain, now that we have access to a lot of block space, is kind of exciting. Like, we don't know yet what we are going to do with everything that we store in terms of history, in terms of things. We have a few ideas that I've tried to put there. But there's potentially many other applications that are going to pop by the fact that we are now able to store historical block hashes of multiple chains at the same place, or just lightly, if you are an L3 that very frequently interact with the L1, well, why not storing the history of the L1 on your L3 since you have a lot of space, and look at this history to do something. So what I'm going to get into more details now is something that if you are running an L3, you can also think about that as something you can run on your own chain in a very lightweight manner, just saying like, hey, I'm also indexing Polygon because I want to do things with Polygon, and Polygon is talking to the L1. And I'm also indexing the L1 because I'm oftentimes looking at what's going on in the L1 to do something in the layer 3. One cool application would be like if you are running a chain called Ape Chain and doing things if letting you stake if you have an NFT on the L1. With this kind of approach, you are able to prove that someone actually owns the Ape NFT that you want to give staking on the L1 to the L3 directly, just by having access to the Ethereum hash history on your chain. I promise there won't be a deep dive onto Rust codes and so on, mostly illustration like this. So this is what we have access to right now. The block number N-256 and the latest block. This is what's available at the moment. What we propose is give a way of actually accessing the whole history of blocks from 0 to, the latest. And what we are going to use is storing the block headers. So everything that you see, I got a pointer. Yeah, it doesn't really work. Okay. Everything that you see here, previous Ethereum block headers, parent hash, beneficiary, difficulty, gas limit, and so on. There's different ways of representing the block headers depending on the fork that you are considering. After the Beacon chain launch and the switch to proof of stake, the block headers have slightly changed, but you're able to store everything. So you're storing the thing in this rectangle here, and inside the transaction root here, you are able also to say, hey, this is a transaction that's part of the transaction root because this is a transaction that's the rest of the tree and it matches the transaction root. So let's store everything here. So one cool thing about Arbitrum is that we get the Arbitrum receipt that let us know about what's going on in the layer beneath. And from what we see in the layer beneath, we are able to interpret that, okay, we should take this Ethereum block to the L2, take this Ethereum block from the L2 to the L1, and now that Arbitrum just sequenced inside the L1, we have access to the latest L1 blocks that Arbitrums know of, which means that from the indexer perspective, we have block number n and probably block number 5, and we can just fill in the gaps between these previous blocks and these latest known blocks. And by filling this gap, we have a recursive way of proving that this is the right block because they hash together from one another. So you are just furnishing the whole history until the block that was lately known, and voila, you have access to the L1 history from your L3. But we can go a little bit deeper. That is, if you are an L3, and you're like, well, I need to really access the Ethereum history really often time because I have this specific use case of just checking if this ape is actually owned by this guy, so I can give him access to this, this, and that. You can run this in a lightweight fashion, but you can also consider that we can create a greater good on running an L3 where we store everything. Yeah, let's have a copy of everything. Let's have a copy of the whole L3 history of all the L3s on top of Arbitrum. Let's have the history of Arbitrum available there. Let's have also the optimism history. Let's have also the base history of the superchains, and so on and so forth. You can store everything inside this L3, so you can start to think about constructing proofs that something happened on one layer to another layer, because all of those layers eventually communicate with the L1. And when I was mentioning EVM chains, it turns out that we can actually also index blocks of proof of work chain very trustlessly, because from a proof of work perspective, we are looking at the block headers and verifying if the difficulty and the nonce produced are actually matching the expectation of the protocol. So you can continue to hash to prove the block headers of Bitcoin, of Dogecoin, and so on and so forth. So with this kind of approach, we propose a novel way of storing everything under the same roof. And potentially, if you are specifically interested by one history, you can also replicate it on your side. We're given the code name 0xv because the decimal of the chain ID that we are using it on is actually 4078, which in hexadecimal called 0xv. If you go on 0xv.io, you have a full presentation of how it can work and how it does work and so on. So, okay, what do we get from that? Let's say that you are either on your own L3 with access to the history of the L1 and the different chains that you are interested in. And now let's take it to a broader generalization. You are on you have access to a node, or you have access to an RPC endpoint. Well, we have access to an RPC endpoint of layer 3 on Arbitrum, where all the history of a lot of chain, let's say the history of all the EVM chains, is actually stored on this place. Now you're able to generate storage proof, which are proofs that a certain transaction is included in a certain history. Let's take it this way. A contract is asking me to prove that I send a transaction to the Uniswap V2 contract. If you remember in 2020, if you had interacted with the Uniswap protocol, you were eligible for a 400 airdrop of Uni token. If you wanted to give a proof that you actually interacted with that, the way to do it is give me a transaction that is included in a block. So transaction tree, transaction root, and give me the chain of hashes from this block with the inclusion to the latest block I know, the latest block I can request. So that's exactly what you get with an indexer using Stylus to generate those proofs. We look at the whole history that we have access to, and we generate a trail of hashes that you can port to any contract for interpretation of, yeah, indeed, if this person is able to show me that this transaction is included in a block with a hash that's matching with the recursively hashed together to the last block I know, well, if someone is able to construct such history and such recursive line of hashes, it means that this transaction was actually included. If this transaction was targeting this contract, well, it shows that this person has interacted with this contract. So storage proof refers to the fact that this transaction is included in the history of an EVM. Now, that's from the L1 perspective, but we can extend that by the fact that we have access to multiple different history of different L2s, L3s, and so on and so forth. And all those layers, at some point in their life, actually every time they sequence, they hear about what's going on the layer beneath. So you can actually compute proofs that something was included in Arbitrum. This refers to the state of Arbitrum that was appended to the L1 on a certain block. And whenever Optimism talk to the L1 again and hear about a later on block, you can actually give a proof to Arbitrum that to Optimism that this transaction was included into to Arbitrum, that appended into this block of Ethereum that you know of. And so from the Optimism point of view, you're like, yeah, indeed, I heard about this block, and this previous block must be included since we have the trail of hash, and this previous block actually contained the state of Arbitrum, and in the state of Arbitrum, I have this transaction included in the state. Well, they are optimistic, those proofs. They are optimistic in the way that you need to wait for the layer that you want to verify the proof on has heard about a later block that happened at a later stage from where you have included the transaction in the first place. They don't tell you much, but they tell you already a lot. If you heard about state proofs that are a little bit more fancy, the state proofs are giving you a proof that this transaction is included and that the state have changed from this point to that point. They are extremely powerful. They give you exactly what the transition was, how it happened, and so on and so forth. The problem from state proofs is that they rely on zero-knowledge technology that requires you to convert the state of the contract that you are interested in into a circuit and generate the proof on top of. Yeah, no code, but we are getting into this type of proofs. What I like to compare state proof to storage proof is in the history of the space race, when the first tryouts of flying without gravity, the US realized that if you don't get gravity, you don't get ball pens to work. Like the ink needs to go down. So they spent about $2 million and something of back then $60 in the $60 to construct a pen that writes in every single direction. So that's state proofs. It's complicated. You need to convert things into a circuit. You need to build a lot of things around that. And eventually you have a proof that the state changed after this transaction. It's big, it's costly to generate and cheap to verify, or cheap to generate but costly to verify. You need to find things and so on. In this case, you can consider the storage proof as the approach of the Soviets. We send pencils, like things that are super easy to write on every direction. Even if you don't get gravity, you get friction, and that's enough. For most of the use case that we could think of so far with those kind of approach, the storage proof are quite enough. So they are bringing some diversity into the ecosystem. It's like it's a different approach than the ZK approach. And furthermore, if the EVM transition to a fully provable ZK EVM, then you get the benefit of state proof as well in the same way. It's also easier to extend and use. They're available. It's just mixing different hashes. They're super cheap to mix together because they are precompiles. And you need Arbitrum stylus to generate those proof and store those proof and order those proof and index those proof in an efficient manner. But you don't need stylus at all to verify them. You just need access to the already available hashing functions on the different layers of Ethereum. So it's very simple to get a proof. In our current implementation, you just get a proof by appending the transaction that you want to prove the inclusion and the block that you want to verify it on. You can also consider a next step as a proof of inclusion from this chain to that chain. Think about the multi-chain indexer as capable of reading what is the latest block that this specific chain knows and that origin chain knows, and computing the trail of hash necessary. And in the midterm, we can do pretty cool things, potentially, like having the Graph API directly on-chain, which will require to consider your contract that will be targeted by this indexer as a stylus contract, speaking to the indexer and indexing the thing that you want to do. And potentially what's interesting from a decentralization perspective is that every chain that gets indexed on a shared layer, doing indexing for all the EVMs, is actually acting as an emulated light node because you have access to everything. It's there. So it's giving resilience also. providing us from being a glorified database. So we did a demo of the utilization of those storage proof at ECC last July. It showed the application of that kind of approach in a chain abstraction on top of account abstraction approach. The approach here is to say that you have a primary safe, a primary smart account deployed on Arbitrum, and this primary smart account is controlling a secondary smart account on Optimism. So we want to say that any addition to the list of owner of this safe on Arbitrum should be reflected on Optimism. So that's a pretty nice use case for storage proof specifically, because in the context of having your smart account on one chain, having your smart account on the other chain, you know the code of those two contracts, you trust the code of those two contracts. So if you consider that the primary safe has received an update, then this update should be applied to the secondary safe as well. And yeah, this is working. You can check you can find easily the demo on the archive of ECC, and we're going to continue digging on that. But we feel like the use cases don't stop at all at the account abstraction aspect. There are many other things that we can build on having a multi-chain indexer. So, well, that's all I have for today. I'm leaving 3 minutes and 30 seconds for the questions. If you'd like to help us build this out or ask some question, you can easily find us, reach out. You can find more info on 0xv.io. And this is an article that one of my colleagues, Johan, wrote of the initial implementation. And yeah, getting there, we are indexing chain histories. Thank you, folks. We have some questions. Wow.
Great. I believe you explained it so well that there's no questions, but thank you very much, Jeremy. It was amazing.
Anytime. Well, guys, enjoy the DEF CON event and the Arbitrum event, and hopefully see you at ECC in Cannes.
Yeah, for sure. ECC is going to be in Cannes. Cannes, it's true. Can. Woo, nice. Well, thank you very much, everyone, for joining us today. There is still a lot going on in ArbiVerse, and yeah, thank you for all the amazing talks and speakers that joined us today. And a surprise for you, this weekend we are participating in the ETH Global Hackathon, so there is $20,000 up for grabs. And also, if you want to keep building on the stylus, right now there is an initiative called Arbitrum Stylus Sprint, and there is 5 million in ARB for people and developers who are building on stylus. So make sure to go to the Arbitrum main account to see where is that announcement. And yeah, you can go and learn more in the Arbitrum Foundation and Arbitrum Portal website. And here is as well the QR code for you to check out the initiative that we have about Arbitrum Stylus. The applications are open now from November 11 to January 6 on Questbook. All the information is there, so make sure to go there. And yeah, thank you as well to our amazing partners. Thank you, Espresso, Bloom Network, Privacy, Phoenix, Open, Arbitrum DAO, GMX, and CoSwap. And yeah, so thank you very much. Thank you for joining us today, and let's keep building Arbitrum together. And yeah, let's get the hats on. Thank you, and thank you everyone who is joining us in the live stream. See you soon.